Should we wait or we should start? 13 people have only joined.
Tony madam.
Yes, shall we start?
We will start.
In this meet, I, Professor B. Bhambar, organizer, welcome you all in the morning session of day 4 of AICT sponsored 2-week second FDP on insights into intelligent automation, machine learning, and data science, where the theme is artificial intelligence and machine learning. Invited speaker for this session is Dr. Dhananjay R. Kalbande, Dean Industry Relations, Sardar Patel Institute of Technology, who is also my colleague in Computer Department at Sardar Patel Institute of Technology. I take this opportunity to introduce you, sir. Sir has obtained a PhD in technology from University of Mumbai in 2011. Sir has been awarded a postdoctorate from Tata Institute of Social Sciences in 2016. He has also been honored as a senior research fellow on the EISS project funded by the National Commission for Women Government of India at EISS from July 23, 2016 to October 10, 2016. Sir was a research fellow on the CLIX project at TISS by Tata Trust and MIT, USA from February 20, 2017 to May 19, 2017. Sir is having 20 plus years of experience in teaching and research. His research interests include soft computing, neural networks, fuzzy logic, computer network, human-machine interaction, decision-making and business intelligence, mobile application development for social cause, ICT for semi-rural development for social cause. Sir have also authored 4 books, namely Graphical User Interface, MIS, Human-Machine Interaction, and Digital Forensics. Sir has also delivered and conducted workshops, seminars, and expert talks on NS2, Neural Network, VB.NET, and AD.NET. Kinsey, the brainchild of Sir, which is a healthcare research startup. Kinsey's flagship product, Dama Photo, is an AI-based mobile application that is able to detect skin disease. There are 6 patented innovative ideas in the name of Sir. Most of the participants have already been knowing Sir in our first FDP, wherein he had made us understand maths for NN, that is activation functions. Today, he will be focusing on the topic problem formulation and solving, where he will be making us learn to translate real-world problems in terms of AI/ML abstractions, formulating real-world problems for AI or ML intuitive and simple algorithms. Sir, we are enlightened to have you on this session, and may I now request you to take over and start the session?
Okay, so allow me to share. Is this visible?
Yes.
Any obstacles in between PPT, means in front of the PPT? Nothing?
Sir, full screen.
Full screen. Just a minute. Now it's fine.
Sir, is it, this is PDF? Sir, this is PDF.
Okay, so no, it's wait, sir. What I will do, I will have a PPT also that I can do. PPT is also ready. I can now. Just check it out.
Go ahead. Sir.
Yeah, it's clear now, sir.
It's clear.
Yeah.
Okay. Good morning. Good morning to everyone, and I wish to thanks Dr. Rathod sir and his team for inviting me to talk on this topic, problem formulation and solving. And before starting my speech, I would like to thank Google, Internet Resources, and all those people through from where I have collected these informations and the data. So I would like to give due respect to all those papers, resources available on internet. Okay, and so let me begin. So problem formulation and solving. So again, one more thing I would like to clear is that the today's talk is completely based on the understanding and the different ways and means to identify the problems and then understanding how this problem after learning can be translated to the AI ML problem statements, and then how you can apply this AI and ML techniques to design and implement it. So let's begin. But here I am requesting all the participants against that here. So some parts are going to be repeated, which is normally the part of any particular instructors, because it needs the concepts to be cleared in between. Okay. Next.
Kalbande, sir.
Yes, sir.
Okay. Right hand side there is some gray box. It was coming. You can move it down or up.
Okay.
So,
Sir.
same. Yes, this same box. Yeah.
Okay.
You simply move it somewhere else.
Yeah. Okay. Now.
Fine. Go ahead.
Okay, sir. So the first very important definition is about problem formulation. So in fact, I'm not the great person to talk on this, but in fact, we all know we are all in the same academics and industry fields and working towards understanding the problems, formulating the problems. Today, everybody is waiting for the vaccines to come as early as possible so that we can have an enjoyable ride towards our institutions or towards our institutes or anywhere in the environment. So that formulation is nothing but we are expecting the particular product. Okay, so in simple words, after understanding how the problem is there and identifying how it can be solved and how it can be formulated, will lead to a particular product. So today's example, I can simply give you the vaccine. Any pharmaceutical product is also one kind of the solution which you can say that after formulating the problem, I will get the particular solution as a result. Okay, so formulation is what actually it is a space of states and actions between them. So it is simply called as a state space. So wherever there are certain spaces remaining, we are always trying to understand the scope from it and then identify what need to be done to bring the improvement. So we traverse it from initial state to the last state, and always our traversal lead to achieve particular goal with some conditions or some set of or some subset of states. So I'm repeating the first point here again. Formulation means is nothing but as a problem, as a space of state and action between them, initial state and goal as a condition on subset of states. It is nothing but also called as the step to identify the user attributes and its need also. So many times it happens that we, without identifying the attributes or a particular need, we normally say use support vector machine, use Navy base array. Means sometimes we always start comparing among the different types of AI, ML or deep learning algorithms, and without understanding whether this particular algorithm will be properly fit to formulate that problem or not, we normally take the decision. So as per my experience, that is a wrong decisions. Without understanding how the problems will be optimized, how the problems can be viewed as the accurate solutions, accordingly we need to understand that particular AI and ML abstract. So it's very important to understand that what type of problem we are facing and how whether it has a labeled data set or an unlabeled data set, or maybe it may be sometimes, it's sometimes reinforced, sometimes we don't have the actual results in our hand. 50% say yes, 50% say no, just like that a bottle is kept in a desert and a person who is thirsty would like to drink it. So there are 50% chances of having poisonous and 50% chances of having it is drinkable. So sometimes, we don't understand. We understand that it is of our need, but finally we don't find the solutions. Okay, so in that case also there are techniques, there are mathematics where you can customize and you can formulate it. So it simply is a step to identify the user attributes and their needs. It is done as a state space search. So normally we keep on searching and getting the optimal solution. At the end, we bothered about whether our goal is achieved, and finally the path cost, PATHCOST. The cost is very important. The cost function is very important because anywhere you design a product now today, everybody is preparing the vaccines and everybody is checking their efficacy, checking their efficiency, checking their immunity. Some vaccines having 95, some vaccines say 90, and someone has simply say the value word above than 90. So what is the understanding whether it is acceptable or not? Depends. Okay, so done as a state space. So normally everybody is everywhere. You can say any researcher or any person always do a search in that particular state space. Example like chess game and water jug problem. I have these two examples in this PPT, which I have taken it from the internet resources, and already I have told you that due respect is already given to all these text and words. If you type the Google, you will also find the same. Okay, so nothing great, but I'm just explaining and sharing my own experience of research with all of you, and I'm trying my best to explain you how this problem formulation and solution in the realm of AI and ML. So next point here is a problem can be defined formally by the following components. Like normally we have the 5 components. So the first component is you should have initial state of the agent. You should know the state of the agent. Now what is agent? Now agent is simply called as a program. It is a simply called as a program. Just like for example, in your home you would like to clean the house, so you need an agent. Example is vacuum cleaner. So vacuum cleaner is an example of an agent. So how vacuum cleaner works in an environment, the main important goal to get it done from the vacuum cleaner is to clean the room. So vacuum cleaner, when we use the vacuum cleaner to clean the room, we move left, we move right. So why we move left, why we move left, there are certain reason. Okay, so that's why AI is there, which can understand and act as per the human reasoning. It can act as per the human perception. Okay, so whenever there is a dirt, then only we can move the vacuum cleaner towards left. Whenever there is a dirt at the right side, then we can move vacuum cleaner right. So it's what very simple. So we need that actuation and sensors in our agent. So agent is very important. It's simply called as a program. It is simply a program. Program plus architecture, you can say. Agent is equal to program plus architecture. Okay. So that is the first component. The second component for the problem is I am talking in terms of the AI ML purely. It is not a general talk. You can simply say the possible actions, and I think most of the PPTs which I am presenting to all of you, I think most of the PPTs are not getting repeated except one or two. Okay. So the possible actions available to the agent is the second component, which is corresponding to each of the state the agent resides in that environment. So normally agent always found in the particular environment. Your environment is where this agent starts working. Okay. Then the transition model describing what each action does. So transition models, whether it is moving left, moving right, moving straight, moving back, these are all actions. Then the goal test, determining whether the current state is a goal state. So if there is a dirt at the left side, so definitely your vacuum cleaner will move left, will sense that there is a dirt, and then try to clean the dirt. Okay, so how much cost it will take? How much cost? Now assume that in a chase example or in a water jug problem or in simple example of a vacuum cleaner, the cost function is very important, which minimizes the loss, in the sense that again another case that it should also minimizes the minimizes the cost in terms of reaching to that particular route. So optimal route finding is what actually you can assume as one of the cost. Okay, minimizing cost or maximizing profit. I have written certain sentences from through my experience. Shortest path finding, optimized solution. So these 5 states, these 5 components are important, which will be used to define a particular problem. So you need the initial state of the agent. Okay, whether the agent is ready on or off. Then the possible actions available to the agent corresponding to each of the state agent resides in the environment. Okay, so you need to understand that environment factors also, environmental parameters. Then transition model, what action is does, its movement, the goal test, determining whether the current state is a goal state or not, means the goal state is what actually to change the dirt and to clean the dirt. Okay, then the cost, the how the cost will be reduced. In that means, in the sense how optimally the vacuum cleaner can move towards the respective path and find out the dirt and clean the room and make your environment clean. So this is what actually. There are more terminologies available in this PPT to explain you. So the next PPT again in general, in the context of AI only, problem and solution. What is the definition of this? What is a problem and what is a solution? So what is problem? In general, a problem is an obstacle. Normally, it's not. I have written in a very general way, generic way. It is an obstacles that makes it troublesome, difficult, difficult to attain a desired goal. Yeah, definitely. That is called as a problem. Sometimes we treat problem as a uh, as a sometimes we treat problem as certain the alternatives which we are going to achieve. No, it is simply called as an obstacle. That means somewhere you need to identify the gaps. Okay, there is a scope that someone needs is not getting fulfilled. Which factor says that that particular need or requirement is not getting fulfilled? That is simply called as a problem state. So a problem is an obstacle that makes it troublesome or difficult to attain a desired goal, objective, or a particular purpose. It refers to a state of affairs, condition, or issue that is however unresolved. In an exceedingly broader sense, a problem exists once an individual becomes tuned into important distinction between what really is and what is desired. Each problem has a particular solution. So this is what actually is the problems. Hope in this workshop of data science, everybody should have this perception of understanding the problem in the domain of this data science, and you have lots of different things where you can look it as a problem, and you are trying to understand which particular AI and ML will be properly fit into it, and so that you can find the solution. What is a solution? Procedure. Solution is what? A procedure that makes the problem navigation towards the goal. A very simple definition. It's a simple procedure that makes the problem navigation towards the goal. So in in AI terminology or in data science terminology, it is simply called as an algorithm or a hardcore implementation to achieve the goal defined by the problem. So every problem have particular goal to achieve. The problem have certain issues, and the problem have certain obstacles. The problem have certain things where the improvement is needed. The problem may have some difficulties which you would like to solve. So solution is a solution is what actually you can say the algorithm in data science way, or it can be an hardcore implementation. It can be algorithmic implementation, or it can be your hardcore implementations to achieve the goal which is defined by the problem. Now problems are of two types. There are two types of problems. One is structured problem and second is unstructured problem. So structured problem or structural problem, you can say, I think it is structured problem only. Structured problems are the ones for which you can refer it as structured problems, not structural. Structured problems are the ones for which there exists a specific algorithm to achieve the goal. I would like to ask the participant. I am teaching to all of you with a respective speed. My speed of talk, I mean the speed is okay to all of you, or I am fast? Should I have to slow down?
Okay, sir. Speed is okay.
Thank you, sir. Thank you. Okay. Thank you. Structured problems are the ones for which there exists a specific algorithm to achieve the goal. The same algorithm is run against variety of input data, still giving a guarantee of the problem being solved. Since the structure of the solution that is in the algorithm remains the same, structure of the solution remains the same, even if the input data changes. Such problems are simply called as structured problems. Example is given to understand about the structured problems, like we would like to sort the students according to their total marks. So the details about the students may be stored in particular database, and the sort algorithm will then get the details of the students. So this is what actually an algorithm, sort algorithm is what actually the solution, you can say. The sort algorithm will then get the details of the students from the database and will solve the problem. Now you may have any kind of particular problem which you would like to achieve from this database of the students, and your own way of creating the new innovative solutions matters a lot. That what you have, what type of solutions you would like to, what type of goal you would like to achieve, what you would like to do. So here the database, that means the data is available in a proper format which you are expecting, and there exists a specific algorithm to achieve that goals, and that's why this example properly fit in the structured problem. Example, another example, the general solution for the structured problem is like very simple. In a layman terminology, we have a backend, and here we have the front end. So backend is a unit which can store the data. Now for any particular participants, apart from the engineering, you can simply understand backend is what actually a database. It is called as a storage. Okay, it is a warehouse, you can simply call that. It is a database where where this students data gets stored in a particular fashion. Okay. Now static data is nothing but a fact. Okay, so backend can be a database system, or it can be a file system. It can be your Excel sheet also, where you store the data. So this is simply called as a backend. I think I have explained in a very simple and generic way to all types of participants available here. Any participants who doesn't understand this terminology, please ask me immediately. You mute yourself and you can talk to me, because some terminology I am expecting that this terminology should reach to each and every participants, and other participants I don't think so it is required. Front end. Front end is a unit that provides user interface and performs complete business logic. So normally front end is nothing but like our you can say a simple front interface which we are normally using. Like if you want to order the pizza today, so you can use Zomato. So through Zomato you can simply log in and you got an interface. Okay, now so that is a front end. Okay, so at the front end you can see the business logic. You want to choose the type of pizza, you want to order the pizza, but before ordering the pizza you also find the route and nearest location. So all this contains nothing but called as a business logic. Okay, so front end is normally is a unit which fulfill our tasks. Okay, which fulfill the tasks which is the user is required. That is a simple business logic. It can be, and this front end can be a program which is written in any programming language, C, C++, Java, or Python, or whatever. As a result, user interacts with the front end of the system to access the backend. So I think these two terms are clear. Okay. Then the unstructured problem. Unstructured problems are problems for which there does not exist specific algorithm to achieve the goal. Very simple differentiation between structured and unstructured. So what steps to take to achieve the goal depends on what is the current state of the problem. AI, that is artificial intelligence, is an attempt to make a computer to solve unstructured problems, and that's why every one of you are learning, understanding, trying to understand the mathematics, regression, classification, annotations, lots of different AI and ML techniques in these particular workshops to understand how you can write a code, how you can write an algorithm, how you can prepare the solutions to solve the unstructured problems. For example, a problem of playing chess or a problem to write a program to perform heart surgery. It is completely unstructured, etc. These are unstructured problems because there does not exist any specific algorithm to solve it. A timetable generation is also simply called as, it is a NP hard problem. It is completely unstructured, undeterministic. Okay. You cannot have the guarantee that the surgery, heart surgery will be performed successfully. No, you cannot have. Even for playing a chess game, you cannot have a guarantee who is going to win. You or opponent is going to win. Okay, sometimes, sometimes such problems are simply, you cannot directly solve by using unsupervised way. These are reinforcement examples. These are the reinforcement playing off. Okay, so you have to you have to pay something back. You have to pay something back. So there is no guarantee. So it is why it is completely unstructured. So that's why getting solution for unstructured data sets uh, is uh, is challenging today, and researchers are working towards getting a good simplified unstructured good simplified algorithm for solving unstructured data sets, which is large in volume. Normally we apply AI, ML or data science for not for only 3 to 4 set of data set, but for large data sets, simply called as, you can say, the big data sets. And many times we always receive the data in an unstructured format. So normally we do normalization. Normalization doesn't help only. Normalization is not only the one way where you can say that unstructured data will come into the structure and then you apply. Unstructured is always also can be studied in context of understanding the AI ML, how it can be solved. Uh, so such examples like chest scheme or heart surgery will be unstructured, where there is no specific algorithm exists to solve it, and we normally use a knowledge base in that case. So normally the general solutions to this such to an unstructured problem will be look like this, that normally it has a knowledge base and an inference engine. We know, I may talk with you about now another concepts of data science. Normally nowhere it is, I don't think so whether it is covering or not, but fuzzy logic also play an important role in data science. Not necessary that AI, ML, and deep learning always applicable. like example, you can say the you can say AC. So it depends upon your humidity, and the temperature. Automatically, today's AC will control the temperature. Will control the operations, that how much coldness will be required in that environment. So the coldness in an environment will be fully controlled, and it is now automated by using a simple fuzzy logic based control system, which is driven and supervised by the neural network algorithm. Washing machine is another example, you can say. It has a knowledge base. It contains the knowledge base, because while designing the fuzzy logic, the researcher has made the research and experience has been collected to understand for how much amount of cloth and how much amount of dirt, how much wash time is going to be required. So user doesn't need to take care. User doesn't need to be bothered about at all things. So automatically fuzzy logic help the system to adapt according to the external environment, according to the external parameters, you can say. So the knowledge base normally contains all the rules. Knowledge base normally contains all the rules in simple language. Again, I am taking one point to, if any participant doesn't understand this knowledge base is normally a rule base. Rules are nothing but, like say, if height of a particular person is tall, that means if a ram is tall, then his basketball skill is good, like this way. Okay, another example I can simply say, if the dirt is large, if the dirt is large, and then grease is also large, then the wash time required will be large. If there is a speed breaker, you are actually, you say, or you are driving a motorcycles, and there is a speed breaker in front of you. So depends upon at what speed, at what distance, how much brake to be applied, at what speed, at what distance, how much brake to be applied. So three variables, x is speed, y is a distance, and z is a brake power. So if else then, if x, then y, like this way. So simple, knowledge base, the concept of this knowledge base and the inference engine in the terminology of fuzzy logic is introduced and developed by a very great person called as Professor Lotif Jadeh. And I think many participants knows about that in management subjects also. The application of fuzzy logic is largely available for solving the various business related problems, and maybe in the case of the financial institutions, you may have to create the large database containing the large number of rules whenever the person is claiming particular insurance. Any insurance you can have, vehicle insurance, medical insurance, accidental insurance, or in case of the mutual funds also, if somebody want to reward the bonus points back. So somewhere, it contains a huge number of rule base which is defined by the expert people. So collection of all those rule base, rules are there in a knowledge base. And with the help of this rule base, the inference engine will take the particular decision. Inference is nothing but called as a particular action, a decision based on, it is a supervised decision, it can be unsupervised decision, it can be reinforced decision. So this inference can be again of the three types. It can be supervised, it can be unsupervised, and it can be reinforced also. So this inference engine has this inference engine is basically used to take a particular decision depending upon the rule base. So here see the 2 points I have not read this knowledge base. It is the collection of facts as well as rules. Unlike database, knowledge base does not store only static data. So it contains all. Inference engine is used to prove the goal from the given facts and rules in the knowledge base. I hope all participants understand this. So today's session is what actually clearing those concepts which you have learned, or it is a relearning for all of us. I am also learning again back by explaining to all of you. Components of AI. Yes, I'm announcing that I may take a break at 11 o'clock for 10 to 15 minutes, having tea break, or party or organizers may allow me. Okay. Okay. Components of AI. In AI, the intelligence is intangible, which is composed of mainly 5 techniques as follows. Now I am taking here back to the components of AI because it's very important to understand the components of AI. So my complete flow of presentation is from problem formulation definitions, then towards components of AI, then small agents and agents to the state, and state to then the case study. So at the end you can see the different case study from my papers where I can explain you how problem is formulated and how it is solved. So now components of AI, 5 important techniques like reasoning, learning, problem solving, perception, and linguistic intelligence. You can see here the intelligence is not means how human reasons, how human being learns, how we perceive, how logically we solve the problems, and the linguistic intelligence, how linguistic normally sometimes the linguistic descriptions, these are these are these are these are prepared with the help of linguistic descriptors. The linguistic, we need to use the linguistic descriptors, like say for example, I have taken an example of this speed. Okay, so speed can have the different descriptors like small speed, medium speed, large speed. So with these combinations, with this combination of different descriptor, if speed is small and distance is small, then brake power will be small, medium, or high. So these are the linguistic intelligence which is sometimes required to be given to the system. So this is what the meanings of all these 5 important components. Like reasoning. Reasoning is the set of processes that enables an intelligent systems to help or to provide the basis for actions, making decisions, and the prediction. There are 2 types of reasoning: inductive and deductive. Learning. Learning is the process of gaining knowledge by understanding, practicing, being taught, or experiencing one thing. Learning enhances awareness of any topic. In very simple definitions, very simple definitions in the context of understanding the components only. Problem solving. I have making it red color. Yeah, today's topic is what actually on the problem solving, problem formulation, and the solution. That's why problem solving is the method during which one perceives and tries to make a desired answer from a present state of affairs by taking some path that is blocked by known or unknown hurdles. So this is what, understand it. We understand it that it's a method. So during this, we normally pursue some data and tries to make some solution from the present state of affairs by performing some actions towards some path. So we traverse along the path and finding what will be the optimal for us. Perception is the method of acquiring, decoding, selecting, and organizing the sensory data. So normally, the agent that I have told you an example, that you have a micro oven, or you have an AC, or you have a washing machine, or you have a vacuum cleaner, or you have any particular robotic arms for surgery. Okay, perception is very important, how it acquires, decodes, select, and organize the data. Okay, perception presumes sensing. Within the domain of AI, artificial intelligence, perception mechanism puts the information acquired by the sensor along in a very, very meaningful manner. Then the fifth is linguistic intelligence. Linguistic intelligence is one's ability to use, comprehend, speak, and write the verbal and written language. It is important in interpersonal communication. So yeah, sometimes it is required. I have told you one example of linguistic descriptors as how cold today is, how hot today is, like this way. So some linguistic explanation sometimes we have to built in our system. I just remember one example of Intel. Before 4 to 5 years back, one of the students to whom I am guiding, I remember the name Sanjeevani, and she used to work on this particular project where NLP has to implement to understand the inputs given by the different people in a linguistic way. So they don't call the different peoples of different expertise. Sometimes if there are certain issues in the Intel, so they have an automated system where they understand the user inputs in a linguistic format and accordingly does the task. So this is what linguistic intelligence is also important in particular cases. Intelligence systems. Now next point is about again the new terminology for this, that everywhere you are learning this data science everywhere to make your system more intelligent. I think this is what is the goal of this FDP, that each one of us, each one of you understand that how at the end you can achieve a beautiful simplified intuitive you can say intelligent system. I think the simply easy to learn and understand. That is in simple. Intuitive means it is very easy to understand. Okay, very simple. So we always want a system which is very much simple, which will be designed, which will be instinctive in way, or which you can say understand the conscious reasoning given by the user. Conscious reasoning, unconscious, no. Conscious reasoning is built on conscious reasoning concepts. So we would like to design an intelligent system which understand this conscious reasoning from human mindset and accordingly act upon. So intelligent systems are the frameworks or a system that may show a type of knowledge. This knowledge was made by preparing the framework with information. However, not utilizing the explicit programming. Example is given, a less complex smart framework could be the Gmail spam classifier. Nowadays, we normally find some of the mails coming in the Gmail in a spam folder. Why? What are those criteria? Okay, so you can understand certain mails and the problems associated with certain mails. Like for example, you are trying to attach a zip file having certain exe or certain .dat file and try to send it. Sometimes the receiver doesn't find it. So might be the intelligent agent at the respective destination understand that this particular file containing some hexadecimal code or some executable code which can be harmful to the system and identified as a spam mail and push this particular email into the spam folder. That is what is a particular criteria. So this is what actually the state space problem, you can simply say, whenever it travels and reaches at the particular state, there the identification about this particular issues will be taken care, and that particular understanding of the understanding the components in that particular file, like for example .exe contains .exe files or dot that file or .bin or any particular files which are supposed to be feels very harmful to the receiver will be identified as a spam and can be blocked. So we need such kind of intelligence system which is explored, or you can say supervised, or you can say framed by the data science data science algorithm, but the algorithm will be intuitive in nature, very much simplified in nature, and should be prepared with the real facts and human reasoning. Okay, and that reasoning should not be unconscious. The reasoning should be conscious. Next point here is about the intelligent agent. I hope all the participants, these all contents are not repeated in the earlier version of all the talk. I hope you people can enjoy. Please don't be. I am also a teacher, expecting that this is not a. I'm not a great teacher, but only trying to explain everything from my experience to all of you. Okay, whatever I have. An agent is a defined. So told you that what is an agent? Agent is defined something that sees, means it perceives. It perceives. Thank you, Pushpa ma'am. For I have just read your sentence message. Thank you so much. It gives me motivations. You know, it gives motivations and energy to recall all those facts which I learn and distribute back to all of you. Finally, at the end, we should be a good distributor. Teacher is a good distributor, and our students are digital library. So I have taken today those examples of my students and assumed it as my digital library, understand it, and trying to explain you the problem formulation through the case studies, which is at the end of my PPT. Okay, thank you. An agent is defined something that sees and acts in an environment. I told you example. So now the examples will come in front of you. Intelligent agents, IA, perform the tasks that will be beneficial for the business procedure, PC application, or a person. So yeah, it's very simple. Intelligent agent perform that task that will be always beneficial for the business procedure. It can be anything. It can be anything. In artificial intelligence, another definitions for intelligent agent, it is refers to an autonomous entity. It is an autonomous entity which acts directing its activity towards achieving the goals upon an environment using observations. How? Through sensors and consequent actuators. That means they are intelligent enough. You can see in the block diagram, you can see here in the diagram environment. Here is an environment where the agent is going to work. So here, you know, there is a sensor. So here is an agent. Now that agent can be your simplex agent or reflex agent. There are so many different types of agents available. Okay. So this is not actually in the scope. Otherwise, it will become completely the talk on the agent only. So you have an agent always have a sensor, and through environment it pursues the information. So sensor pursues this information from the environment and accordingly take the actions. This is what an action symbol. Yes, once it receives the inputs from the environment, this agent receives the information. This agent receives the informations. That means it perceives the informations and then it acts upon. Okay, and accordingly, agent can also take the actions back. Okay, he can move back, he can move left, he can move left or right, whatever may be. So there are different agents, like see example, human agent. Human agent has sensory organ. We are also, we ourselves are a very intelligent and conscious agent in the world. No one can beat us. Okay, not a robot also. But today we feel that today's robots are dominating us. Today's chatbots are dominating us. This is a fact. Yes, it is a fact. Who made this chatbot? We made this chatbot. So we made them enable so that they can dominate us. So we make them so intelligent that they can. But this is not the fact. Okay. So human agent has a sensory organ like eyes, ears, nose, tongue, and skin. These are all sensory organs parallel to the sensors, and other organs such as hands, legs, mouth for effectors. So see, our sensors are eyes, ears, nose, tongue, and skin. And organs, the effectors are we move our hands, legs, or we can talk. Okay, we normally doesn't keep uh, cool. Sometimes you can hear somebody's message which feels very much, sometimes, very insulting. So we say immediately. So effect will be through the mouth. So there are always sensors and the effectors. So sensors receives the information, perceives the information, and effectors will take a particular action, so movement actions. A robotic agent replaces the camera. So in case of robotic agent, it replaces the camera and the infrared range, finding the sensor. So through camera, it perceives the informations and various motors and actuate and various motors and actuators for effectors. So there are different you can say the actuators which are assembled with the robots to take the particular movement. That is case in case of in various case you can see the robots in the manufacturing industries. You may have the robot in a big warehouse, like you want to sort. For example, say for example, I'm taking an example of my place. In our area of Vidarbha region, we have the orange factories. So in the orange factories, we have seen a sensor, and that sensor is beautifully, it is intelligently built using the concepts of simple Hebb network, neural network, linear separable concepts. You already have learned that equation y equal to mx plus c. Lots of learning, lots of mathematics you people have already learned. I'm just correlating the example of an orange factory, that there is a conveyor belt over which the different types of fruits are moving. So whenever the fruits type like orange or an apple or an banana or something else, okay, whatever may be, comes, so the main task of the sensor is to sort it out according to their texture and the shape. Is it possible? Yes, it is possible. I think I have took one example, maybe in activations also. I don't remember whether I have taken, but that is what one example of the robotic agent, that you have an agent in the manufacturing industry in the form of such which can separate out the different types of toys, which can separate out the different types of fruits. You may have a robot in a manufacturing industry where human hands cannot reach. The robotic arm is reachable. Robotic arm can reach to that particular point and it does the welding tasks. Okay. So the design of such robot is very important. We have seen the design and implementation of the robots for the various types of applications in today's medical field. You can also find the robot precisely calculate the area of a tumor before surgery, before getting operated by the ontologist. Ontologists also need an help. He can do operation with a conscious region which is intelligent. Robots are there to assist them to know the actual size of the tumor available, of actual size of that malignant object available. Who made it possible? Today's data science techniques made it possible with the help of image processing, or you can simply say computer vision. So that bounding box can be created. You can simply inherit the bounding box object from model.py file in Mark's RCNN concept. In case of Mark's RCNN concept, you can simply call the bounding box object to bound that particular object from an image and count the x and y dimensions, and or you can simply count the number of you can simply count the number of pixels. You can aggregate those pixels. You can simply understand how much volumes it has. This is a simplified logic. So I can start from the initial state. Okay, x and y will be 0 0, and then I can start searching and first finding wherever the mask pixels are available. I am aggregating those pixels, and that particular you can simply call it that particular code, that particular procedure help me to go get the actual size of the tumor. Okay, that is what actually. So robotic agent, don't simply assume it is an agent working simply for simplified. It is There are agent, you can find it towards the toll naka. Okay. So it simplified our tasks. Okay. In today's corona situations, we don't want to open the window, so we can simply show our smart card, and there is a sensor which sends the card, and if it is valid, it deducts the money and allow you to travel. So there are different ways and means to identify and do. So our perception matters how we treat it. Otherwise, you cannot say all applications are only in the field of the data science. Okay, there are different applications in different fields. You may have different examples. You may have agriculture. In agriculture also today it is important to have the robots to understand the type of soil we have. Is it possible? Yes, it is possible, but we should have the knowledge about the soil also. So one can simply say it's a task of civil engineer, someone say it's a task of the farmer, someone say it's a task of, oh, I'm a computer engineer, I know only how to write a code, but at the end, your solution should be optimal, your solution should be acceptable, it should be acceptable by the farmer, it should be understand in the way the farmer needed. So that's why a problem formulation is very important. Getting finding the solution or writing a piece of code is simple, but getting that particular solution reachable at the respective user end is very important. Fine. Software agent is what actually it encodes the bit strings as its programs and the actions. So three types of different agents are there: human agent, robotic agent, software agent. You can have different agent terminologies. Normally, when we use an agent, so agent, the terminology agent is what actually in program. It's in solution. You can simply say the solutions to solve the particular problem. So normally we need to write a piece of code. I hope everybody understand the pseudocode, the algorithm. Normally it is in earlier days, we have used Fortran and the Pascal to write the pseudocode for the problem statements. Why not today? Is it possible for you to write the pseudocode in the Python? Yes, it is possible. It is possible. What is required to understand the syntax of the particular programming language? Begin, process, every algorithm has a begin, every algorithm has a particular task to do, and every algorithm has a particular condition also, and every algorithm has a particular end also. So your pseudocode starts with begin, you have various states available, and then finally you have to end it. Or might be if it is not if it is not a if it is a function, or if it is a procedure, might be that particular function will pass the value to another particular function. So it can be, you can have a various another state. The one state can be connected to another state. So one process will be completed, it can pass the thread, executed thread, to another process. So this is how you can also perform this multi-threading concepts while designing an agent program. Okay, that is what actually the in depth about the understanding of a piece of means what I can say, understanding in the terminal in the context of the data science. Otherwise, we simply say creating a data set. You have a data set, create one folder of train, create one folder of train. What is okay? After this, then you read the data files. Okay, I have read the data files. Then after this, you write a particular algorithm. Yes, I have written the particular algorithm. Then print the output. Okay, I have print the output. Then plot it. Okay, I have plotted. Okay, I got the result also. Okay, I got that. I understand that the problem is now linearly separable. At the end, it should be usable in the way the user expects. It should be usable. Okay, that's what I'm talking in terms of application point of view here. That's why I have told you. Otherwise, sometimes we need to have to understand problem formulation in the form of when you are designing your own algorithm. So definitely different states, different parameters are there, like completeness, time complexity, space complexity. All these are the different parameters which need to understand while formulating a particular solutions towards particular problems. Okay, at the end. So performance agent, performance measurement of an agent. It is the criteria determining the success of an agent. So that is performance. So success of an agent is simply called as the performance measurement. Then behavior and action of an agent. It is the action performed by agent after any specified sequence of percepts. That is a behavior. Percept. Percept is what? The perceptual inputs at a specified instance. How it receives, how it reads the data at a specific instance. Percept sequence. It is nothing but the sequence of percept, sequence of reads, you can say. It is defined as the history of everything that an agent has perceived till date. So sequence of data, you can simply say, series of data. array of all those read sequences, you can simply say. Agent function defined as a map from the percept. Yeah, it's a spelling percept. You can say percept sequence, not precept. It is defined as a map from the percept sequence to an action. So simply agent function is equal to agent is A is equal to f of P, where P is the current percept and A is the action carried out, and F is the agent function. So A is equal to F of P. What is A is the action carried out. What is F is the agent function or current percept or respective parameters. So all are simply called as an arguments, the inputs which you would like to give. So F, sorry. So F, sorry, just a minute. Something is happened. Let me move the mouse. Now it is static. So F colon P corresponds to A, where that means F maps percepts to the actions. Yes, F maps percepts to the action. So agent function, where P is set of percepts and A is all set of actions. So generally an action may be dependent of all the percepts observed. Whatever percepts we observe, all the actions are dependent on it, not only the current percept. So that's why now it is written. It can be written as AK is equal to F of P0, P1, P2 to Pk. All this P0 to Pk is nothing but the sequence of percepts recorded till date, and AK is the resulting action carried out, and F now maps percepts to sequence to actions. See how F colon now P star, that means there are multiple type of percept, that's a sequence of percept. So sequence of percepts can be written as P star. P star maps to P star corresponds to A. So F colon is equal to P star corresponds to A. So in case of AI, so this is what the little you can say the concepts related to the design of an agent, where we have to understand these three important variables F, P, and A. I hope everybody understand what is F, okay, what is P, and what is A. The next is please keep in mind. I may ask you. I don't want to ask any questions, but please keep in mind what is F, what is P, and what is A. Okay. But now the next concept is page and PEAS. Page. Many of you available here in this today's sessions, and I know you people have already taught this subject, so this particular part. But for those people who doesn't have read this, is will be very much helpful to know what is page and PEAS. Because finally at the end, problem formulation in the context of in AI and ML, you must understand what is page and what is PEAS. Then only problem formulation and finding or writing or preparing a solution using the abstract notation of AI ML will be very much simple, and then only your program becomes very much intuitive in nature. Everybody needs program to be intuitive. Everybody needs program to be simple. Yes, everybody needs at the end that whatever the device coming in the market should be very much simple for me to understand. Even though you purchase a mobile, you first of all see rather than functionality whether I can able to operate it or not. It is but we never tell to the operator, we never tell to our friend, I have purchased the phone. Might be it is possible that many of us don't understand even the internal functionality, but we take it from the look only sometimes. But finally we also say 128 GB, we need 128 GB RAM, we need this much amount of camera resolution, we need this much amount of functionality, we need this, we need that. All thing is okay, but you think about that particular device, your mobile. Okay. So how it receives the information, how it performs the action, what type of goal, and in which environment. If you put your mobile into the water, is it a waterproof? So such type of questions always comes in our mind. I'm just relating this. I'm just relating with a simple example. So page the next PPT having the definition, the understanding of this PAGE. So this PAG here, P for perceived, A for action, G for goal, and E for environment. Okay, and PEAS, that is performance, environment, actuator, and sensor. So I think this is enough. Quite if you Google it, you can simply understand. Perceptions, I told you the inputs which you can take. Action, that is A, goal which is going to be achieved, and E is an working environment. No audio? Yes, now it is audible. It is audible.
Sir, everything fine, no problem.
No, someone has typed in a box, so that's why.
No, it's okay. Continue.
Okay, so the two important component of AI is there, like page and PEA. So told you about what is perceived, action, goal, and environment. It was a simple example I have already explained you. And then the another at the other side you have these four important components again: performance, environment, actuators, and sensors. So we will see. So now very important to understand the working environment, the environment of the problem. So always we all are ready to give the solutions to everyone, but understand what is an environment. Okay. So environment is also important. Sometimes it may happen that the problem may be solved. Your algorithm may have the solutions to the respective set of environment, but not compatible with the other environments. So then what is the use? So in that case, our algorithm fails, and then again we need to rewrite the code. We need to understand that those environmental parameters. We need to fine tune it, and lots many things happen. So why not before before understanding before understanding how I am implementing the solution, why not we understand the environment also? Okay. So there are so many different environments. Maybe in the next PPT I have, but this environment of the problem is very much important for all of us to understand. So vacuum agent perceives in which square it is in. Yeah, vacuum agent. So you have a vacuum cleaner. So it perceives in which the square it is in. So wherever it is placed, so whether that particular square is clean, so it doesn't take any actions. If it is dirty, it may try to suck. Okay. So and if there is dirt in the square, it may choose to move left. It may choose to move right, suck up the dirt, or it may do nothing. Also, this is what actually the vacuum cleaner can do. On the basis of the aforementioned tasks, one of the very simple function of the agent is the following. What is that? If the current square is dirty, then suck that dirt. Otherwise, move to other square. Hence, we can write. Similarly, it happens in chess example also. If you want to move the pawn, now I'm not an expert in a chess, but understand little much when the different means movement takes place by the different pawns. So here also a simple example. If the current square is dirty, then suck, otherwise move to other square. Hence we can write. So perceives here in perceives the location and the status will come. Example, location may be A, then it has a dirty, then actions left, right, suck, and no drop. So if A is A and dirty, do nothing. So see the pseudocode. See the pseudocode. This is what actually you can say a simple abstract notations which we can use while writing a Python code for a particular problem. So you may have to write a Python code or an intelligent design an intelligent program which can understand all actions of vacuum cleaner. Okay. So and you also have to write all those four to five functions in one program to understand how vacuum cleaner works. So you need to understand the agent and you need to understand its various states, how vacuum cleaner works in an environment, its movement, and depending upon the dirtness, whether it is moving left or right, or whether it is stop, whether it is moving back, like this way. So function reflex vacuum. This is simply an example of the reflex vacuum agent. So returns what it returns. Okay, so see this agent works on these two important arguments. One is location and one is the status. The location is A and status is dirty, for example. So it returns action. What it returns, it returns actions. If status is dirty, then it returns suck. If the status is dirty, then definitely it will suck the dirt. If location is A, then return right. If location is B, then return left. Return action. So every function has certain return statement. So the return it will definitely return certain output back. So I think hope you understand this. You understand these four important points here. They are very simple, very simple. function reflects vacuum agent and the two arguments location and the status. And so this function returns action if status is equal to dirty, then it returns suck. Okay. So if status is dirty, return the suck. If location is A, then return right. Because A, if suppose A doesn't have anything, then it will return right. If location is B, then it will return it. Okay. So depends upon if the location of an agent, it can move left, it can move right, or it can suck the dirt. This is what is actually the example. Vacuum cleaner problem, performance measure of vacuum cleaner agent. All the rooms are well clean. We are expecting from our vacuum cleaner that it must clean the environment, it must clean the dirt. Okay. So that's the performance measure. Behavior or action of an agent. It definitely your vacuum cleaner will perform different behavior. Yeah, definitely it will perform certain action. It will move left, it will move right, it may suck, or it may doesn't perform any operation. So these four actions are there in your problem. That when see you have the specific problem in your hand. Now you are going to formulate it, and after formulation your algorithm must give certain solution. Now you are formulating for your vacuum cleaner. Understand with the help of this vacuum cleaner simple example, you are creating an intelligent agent which will understand your objective, your goal is to clear the dirt, to clean the environment. Okay. And you need to understand the behavior, how this agent will act in an environment. What are the various possible actions the agent can take? Agent can move left, right, it can suck the dirt, it cannot do any operation also. Okay, so finally your agent, your vacuum cleaner agent. So all the percept sequence will be properly mapped to an action. So F is equal to P star A. Okay, so all percept sequence to the action. So F always maps all sequences to action. Okay. So F always maps all sequences to the action. So another in a very simplified way, these are the percept sequence for simple understanding. Purposefully, I have taken this PPT to understand again percept sequence. Once you understand one simple example, you understand the whole PPT. Means in the sense the main objective of today's talk that is not only giving the final solution but understanding the various steps inside it, understanding the environment in which that particular agent will work, and accordingly you can create your formulations. Formulation involves various functions, various procedures, various states, various types of you can say the action statements which will used by the agent to carry out the respective actions. Okay. So percept sequence, if your agent is at A location, then it will clean. That means what action it will take? A, so it will be action it will right. Then second, if at location A and it is dirty, then it will suck. At location B, that is more left action is there. If your vacuum cleaner is at location A, then it is already clean. That means that location is already clean. Then status is clean now. So that's why it move right. Again, it found dirt, then it will suck it. If it is again at the location B and if it is found clean, then it will move left. Okay, if again at location B found dirt, then it will suck. Now, if A at location A and if it is dirty and A clean, then it will be right. A clean, B dirty, it will be suck. So like this way, all. So if it is both A and B at both location there is a clean environment, then no operation will be performed. Even at B and A, if there is a clean environment, then no operation will be performed. So understand different states to be occurred in your respective problems, and your way of writing a piece of code means your way of writing the different states using the various algorithm should be very much clear. So this problem formulation, I think, hope everybody understand. Right now, it is very much clear that whenever you would like to write a simple algorithm, wherever you write a simple algorithm, might be you can many of you can simply identify, sir, I can simply use it. If fails, then yeah, definitely you can use it. Okay, you can use it, but what happens that you want your vacuum cleaner to operate and automate the tasks. So how it takes place? So this understanding different percepts of sequence and actions and properly mapped into the agent is what is important. The next is the page. While designing the intelligent system, there are following four main factors to be considered. Page, P for percepts, the inputs to your AI system. Percepts, that is nothing but inputs to the artificial intelligence system. A, actions, the output of the AI system. Goals, G, agent is expected to achieve, and the environment where what the agent is interacting with one. In environment, agent moves and starts performing an actions. It's a working environment. It's a working, you can say, surroundings where your agent is operating. So while designing any intelligence system for any particular problems, these four factors are very, very important. Always formulate your problem statement for any kind of AI and ML related ML related tasks into this four. You understand what is an input, that is perception, how it perceives, what actions, age. You can note down these parameters on the book, or you can keep in memory that these four need to be achieved. What are the goals which we are expecting from our agent to achieve, and in which environment? Many times it happens that we design a system, and then finally we just keep it on the Google for understanding, and there is no use as such. So we understand only one environment where we think of, but might be the user doesn't find it useful because you want to use the intelligence system in another environment. So there your system fails. So understanding the agent interaction is also important. So this is what is page. Now these are the examples. Here we will now discuss this, and any one of the participants, I would like to ask any one of the participants who will explain me any example, any agent type is given, medical diagnosis system is given, satellite image analysis system is given, part picking robot is given, refinery controller, and interactive. Choose any one of the agent type and explain in your way what you understand this for PAGE. So I would like to invite any one of the participants and explain in your understanding, then I will be happy. So choice is yours. Lots of examples I have told you, means very one example I have explained you to explain percept, action, goals, and environment. So here the examples are given in front of you. So choose one example and explain me in your way. So what you understand from this PAGE. Can anybody take the advantage of the same? Then after this, we will take a break, sir, for 10 minutes. I need a tea. So 10 minutes for discussion, sir. Rathod, sir. Dear participants, please
Yes,
speak
sir.
with
Yes,
me.
sir.
Yeah. Dear participants, please speak with me. I cannot see.
This is Dr. Pushpa.
Yes, ma'am.
Actually, as you have told that page is wherein we are trying to build a structured system for any of the robot to work. So in this medical diagnostic system, so generally we have to perceive that, okay, what are the things that the diagnostic services have to do. So
Yes.
what it will try to do is it will try to identify the symptoms of the disease or illness. Then it will try to see that, okay, what are, if at all the test results have been given, then based on that or whatever the patients are responding to them. So
Correct.
everything it have to perceive it, and based on that we are trying to go with the actions. So based on this, we have the doctor ask the questions or
Correct.
the system ask the questions. Then based on the test request, if at all some tests have been have to be done. So based on that, we will try to see, or otherwise we can suggest that, okay, what type of treatment can be given, or what are the referrals that they are into. So this
Correct.
is the action, because based on the perception we have to design the action.
Correct.
Then what is the actual goal? Because we have to see that we are having the patient's health to be cured, the illness to be cured, and at a level of minimum cost. So that is the ultimate goal for us. Whenever we are designing this system, we are trying to see that we are helping the patient by minimizing the cost of the patients. And the environment, what we are taking into consideration is we are taking the hospital environment, the staff environment, which will be supporting, and the patient, that is the person who has been acquainted with the disease.
Yeah. So one more point can be added in an environment in today's COVID situation in environment, that is home. Today, using telemedicine option, it is possible for the doctor to give certain advices to the patient at home also. Today it is possible.
Yes.
So patient may be at home and you have the telemedicine options available, and today's many doctors are trying to provide the treatments and the referrals through online way also. So here in a environment, the home can be added.
Yeah. So for any type of the agent or for any type of the design what we are making, it's very important that the page have to be very clear, like what are the different aspects that we have to perceive from each and every angle we have to take, and based on the goal, we have to design the actions that we have been supposed to do. So that's what I understood from this slide.
Yes, ma'am. It's very clearly you understanding is very right and clear, because before formulating the problem and providing the solutions, this page is very much important to understand, which helps us to understand the requirements, which helps us to understand the inputs, the actions, the goals, and the various types of environments in which your algorithm or the solution which you are trying to give are going to operate upon. Thank you so much. Thank you so much, ma'am. And I'm requesting one more participant to choose one of the example and please explain. I'm requesting one more participants. Then I will be happy. It is in front of you. I have not asked you a difficult question. I have not taken another agent type. I have taken only the type which is there in the PPT itself. So requesting one more participant, if interested.
I can make out, sir, again another also. So if at all you don't have any problem or objection.
Yes, madam. Please.
Yeah. This part picking robo, generally we also now see in foreign countries or wherever we are trying to utilize these part picking robos, and maybe in India also we can use this for cleaning purposes. So here what the part picking robo will do is it have to actually identify the particles that it have to pick, or any of the things that it have to pick. So what it is perceiving, that is the perception of the stimulus for this robo is whatever the items that it is having. So they are definitely of varying intensity, varying weight, varying colors, or varying properties. So we have to give the programming for whatever the different styles of the particles are there. So the perception is the pixels are varying intensity and color. Then what is the action that it is supposed to do? It have to sort out, because it is having of different sizes. So they have to see that we have to ensure that different items are being sorted out and they are being replaced into the correct bins. So what is the goal? Goal is wherein we have to identify, because some are small, some are big, some are wet, or some are dry, or some are of which colors. Sometimes we have to sort out in the machinery that some color balls of same color. So here the sorting based on color intensity, we are having different bins. So our goal is where we have to place the parts in correct bins. So for this, what we are generally using, we have to create an environment with a conveyor belt with parts and bins, so that this part picking robo is utilizing this environment to do these operations.
Absolutely. Yeah, absolutely correct. Thank you so much. Thank you, Pushpa ma'am. And now requesting all of you to even Rathod sir to have the 10 minutes break. So, sir, when we will meet at, can we meet at 11:22 is there? So, can we meet at 11:35?
Sir, your choice, completely your choice.
So, we would like to give have 10 to 15 minutes break, have a tea. Sir, 10 minutes,
Okay.
10 minutes break, huh? 10 minutes break, huh, sir? I am unmuting
Okay.
myself. Yeah, yeah. Thank you so much.
Yeah, I will send you a picture of tea on WhatsApp.
Thank you, sir. Thank you.
Okay, you apply your ML algorithm and extract the tea from picture. Thank you.
Okay. Okay. Hello, sir.
हाँ सर. Yeah.
Oh. Hello, should I start now?
Yes. The slide is also visible. Everything clear, sir. No problem.
Okay. Thank you everyone for giving me 10 to 15 minutes break for tea and nasta. Thank you very much. Okay. So we will continue. Thank you participants for giving me an explanation and understanding of the two examples. For PAGE, for percepts, actions, goals, and environment. And everybody has understand how this page parameters are very much important, and it has and it is really significantly important while formulating any problem statements. Now, very simple example just I have given. The other reflex these are the different types of agent: simplex, reflex, model based, goal based, utility based agent, and learning agent. So main task is not to explain all this about it, but only to give you an idea. Other things you can just Google it, you will get much more information than this. So that's what only one simple example I can give you, that is about simplex reflex agent. Like if it is raining, then put up umbrella. Just okay, if there is a car in front of you, then you can simply apply the brake. So this is what simply reflex agent. So if you have a speed breaker in front, if you have a speed breaker while bicycling, then we normally slow down the speed. So that's a simple. That agent simply understand the condition which is there with the if statement and perform the action after the then statement. So if it is raining, it is a condition, then put up umbrella, it is action. So it is very simple reflex agents. Similarly, there are other agents: model, goal, utility, and the learning. Okay. Now this is for the environment. Environment. These are the types of environment. Many times I have discussed with you about this environment types. So various types of environments are there. The first row is about fully observable environment, deterministic environment, fully observable or deterministic or episodic or static or discrete or single agent. Okay, there are different understanding is given in the Google itself. What do you mean by fully observable? What do you mean by deterministic environment, episodic environment, static environment, discrete environment, or single agent? Okay. If I keep on taking them, I think these 3 hours is not enough for me. Okay. So I'm just taking a shortcut for this about the example and the type of agent it is. Okay. If you want it to be in details, then you can further contact me. I can provide you the material so that you can understand what is fully observable, what is deterministic, what is episodic, what is static, what is discrete. Okay, not now. So the example here it is what is I just assumed, and sorry for those participants who cannot understand easily. If I keep on explaining all these things, then the time will be very much time is limited, so I cannot. So the example is solitaire. Everybody plays solitaire. So it is, we know, deterministic, and it is episodic, it is static in nature, and it is discrete in nature. Yeah, there is a single agent, one at a time. Okay. One in the sense there is a single agent. Yeah, there is a single agent. Okay. Today is, Tin Pata is an online game which can be played. One opponent is there, and one you at your side, you will be there. So that opponent side is simply an agent. Okay. It is a single agent which works according to the opponent's move. Okay, and always try to fail you. Then there are other examples like say taxi driving. There is nothing. There is no such environment. Then internet shopping. Yeah, it is discrete. Yes or no. Okay. Normally we say yes or we say no. We never say 50% chances that I can come and I can take. Okay. So it is discrete in nature. Yes or no only. This internet shopping example. So environment type is discrete. Similarly, there are others like in medical diagnosis. Again, there is a agent, one agent that is simply called as a doctor or an expert who operate on it. Okay. And today's AI make it really it is making it observable, but in theory and in the textbooks by the different researchers, these are the examples and the parameter comparative study is given to understand the environment types for various examples. Okay, so don't want, because it may take again 1 hour to explain me one and each and every one. So if you want in details, I may share my PPTs based on the environment types and understanding of what is fully observable, what is deterministic, what is episodic, and any other things. Then the next is about the PEAS, that is PEAS for agent. PEAS, that is performance measure, P for performance measure. So example is given. This is for the automated taxi driver. The performance measure will be safety time, legal drive, and comfort. The environment in which the taxi driver is operating is on roads, and it can be other cars, pedestrians, and the road signs. These are all parameters will come in environment. Actuators are nothing but the steering, the accelerator, the brake we use, the signal we see, the horn. These are the actuators. The sensors are nothing but camera. Now in today's era, we have different types of cameras inbuilt in the car, which helps us to park the vehicles very properly. We have odometer to smell. We have GPS system to use the internet and to access the location. We have accelerometer also. This accelerometer helps us to understand the the bumps on the road, the potholes on the road, and if you formulate that particular problem and integrate with the accelerometer parameters of the sensors, you can write a piece of code to understand to recognize the particular bumps on the road using the accelerometer feature which is there with sensor. Then you also have an engine sensor to understand the quality and the efficiency of the engine to be used. Okay, and the keyboard. So these are all the sensors. So this is what actually very important parameters to understand for agent, performance measure, environment, actuator, and sensor. Another example will also clear this idea that for vacuum cleaner, which I already told you multiple times, performance measures is what actually cleanness, efficiency, distance travel to clean it. That is what is the main important is the cost parameter. Okay, how much distance. So it should take always minimum distance to travel to clean. Okay, now because if it takes minimum distance, the minimum battery will require. Correct now. Then the battery life and the security also. Environment in which it is vacuum cleaner operates like room, table, wood, flower, carpet, different obstacles, anything. The actuators can be wheels for movement, different brushes to clean, and extractor. Okay. And sensors are camera. Today vacuum cleaner vacuum cleaner. We don't need to drive. They drive itself. Okay. So self drive vacuum cleaner. You can simply say self drive vacuum cleaner. Self drive vacuum cleaner. Okay. So that it may have camera. It may have dot detection sensor, flip sensor, bump sensors, infrared wall sensor. So many things. So it cannot directly hit on the wall because it has an infrared wall sensor. So this is what actually understanding these four important parameters helps you to understand the important components required for designing an expert system. So once you understand these four parameters, you can formulate the problem according to the requirement which you are expecting from your expert system. So now writing a AI/ML code for automating the taxi driver operation or writing a AI/ML algorithm for vacuum cleaner operations makes easy once you understand this PEAS. I think so. This is one example. The example you can see the image that is a driverless car. Many times you have heard this example from many speakers. So today's driverless cars, yeah, they having these four parameters inbuilt in it. You can read white paper of these driverless cars. You can find these parameters and its explanations how they have achieved this. Okay. But on Indian road, it is difficult. But on the road where it is population density is very less, there this particular concept will be running properly. Not in our. It needs little smarter city to make the use of the driverless car. Hope everybody will agree. Okay, so now I am moving to the next part, that is the towards our theme. Main components. So far we have seen what is problem formulation, definition, problem solution, the agent, types of agents, the different functions, agent function, how it maps sequence of actions, sequence of perceptions to the actions. Okay, and then we have taken examples also of page as well as PEAS. Now moving towards next, that is components of problems in AI. So most of the components of problems in AI consist of the five parts. It has a state space, it has certain initial solution, initial situation, it has an action, it has a goal test, and it has a path cost. So these five parameters, these five parts are very important to understand how you can formulate the problem in AI. Any kind of AI application has these 5 important parts: state space, initial situation, action, goal test, and path cost. In other words, you can see that it involves the problem formulation and solving involves the 4 important steps. What are these 4 steps? First, define the problem precisely. The definition must comprise of precise specification of initial situation as well as the final situation with some acceptable solutions to the problem. So you should understand that if you are formulating and understanding the situations, but assure that it should give you an acceptable solution. Okay, define the problem in that way that it should be measurable. Yes. Then analyze the problem. Analyze the problem. Don't try to code it immediately. Once you understand I can write a code, and my code will be very intuitive and very innovative in nature. No, you need to analyze it first, whether really it is the final solution which is acceptable and measurable. If not, then you have to define the problem statement again. So from second step, again, you can go back to the define state. Okay, then analyze the problem properly. Then isolate and represent the task knowledge which is required to solve the problem. You need to analyze. So after analyzing what type of problems you have, whether it is different ways of analysis. Again, this is a bigger topic to understand how problem analysis takes place. Okay. So isolate and represent the task knowledge. Isolate the task knowledge which is required and represent it in a graphical format so that you can understand how the problem can be solved. So that means it reflects to give you the process flow diagram, a DFD data flow diagram, or you can say the transition diagram or an activity diagram or simplified unified modeling language diagram, UML modeling you can say. Sometimes some people say water flow, some say spiral model, whatever modeling techniques and graphical techniques available, you can use this to understand and represent the task knowledge required to solve that particular problem. Then only it is possible for you to understand every components inside it after analyzing. Otherwise, what's happened, sometimes we may miss to propagate back the particular tasks, and then we understand, oh my god, here if I try to get it back so that the weight updation will takes place again, so that I can again fine tune the accuracy, and then only the final solutions can be reached. So sometimes we miss that particular states to link it back, and then normally we don't have an options available to reach towards the optimized solution. So this is always happens. This is always happens with me and you, everyone. Then the last important steps is choose the best problem solving techniques and apply it to the particular problem. So now how to identify which is the best problem solving techniques is what actually understanding what I have told you about page and PDAs, about agents, about state space, about cost path, about everything. Don't be hurry in solving the problems, because today about most, I think many of you know about all types of AI techniques. Many of you know about Many of you, somebody have used Prolog language and the Lisp programming. May you have used Prolog. If you have used Prolog, then you can formulate the problem. You can formulate the problem using a simple English sentence. So earlier days we don't have the Python, we have the C. Before C and Pascal, we have the Prolog language. So normal. the- Let me take a water. So what I told you about the identifying the best problem solving techniques. So it's very important, and then apply it. So identify whether it is of type regression, whether it is type classification, whether it is single class classification, or whether it is multi-class classification, whether it is supervised or unsupervised, whether it is simply a classifier you want to take, whether it is simply a decision-making model, whether it is simply a card distribution type of application, whether it is simply a simple decision-making application. You have variety of problem solving techniques available, but how to choose the best one which can give you the acceptable solutions to the problem is very important. Just blindly I know SVM, then I will apply SVM. No, I know Navy base, then I will apply Navy base. Oh, someone has already done find it out using K nearest neighborhood, so I will also try using K nearest neighborhood. Oh, someone has already done coincident self-organizing, so I will also try using. No, it is not like this. It is what actually normally we researcher always think of using something different so that we will get something different in our paper and we will get our the qualification back. This is not the case. Solving the problem is actually giving the acceptable solutions to the people to whom it is actually required. So you need to focus on whether the problem which you have identified and you are starting preparing the solution are fulfilling the need for which it is created or not. Otherwise, there is no sense as just taking and using. Most of the times it happens with me and you also. That's why I told you it happens. But this is a very difficult task to find out which is the best problem. So identify whether the problem is of type NP hard or NP complete, whether it is deterministic, whether it is non-deterministic, whether it has a maximum. So identify how much, what is the data size, whether the data set is labeled or whether it is unlabeled. Lots of different things are going to be considered. This is the last final step, is very much crucial and very much unconsciously. We cannot assume whatever I know is best to solve the particular problem. Absolutely wrong decision. Absolutely wrong decision. We all know our limitations and the knowledge and the skills which we have. But normally, if you really understanding this PPT and my talk, so the last step is very important. You have to analyze and study multiple times, multiple papers have to read, and then only you can identify, oh, there is a scope. You can simply cannot say that only changing the parameters will and applying the same algorithm will give you the good and accurate results. No, this is not the fact. So one side we say it is innovative, another side we say it is intuitive. Understand what is innovative and what is intuitive. Intuitive, consciously, very simplified solutions we would like to provide. And innovative, in the sense whatever the peoples have not yet done and not yet tried, you are going to try something different. And that's why it becomes challenging, which is not visible to you, and that's why normally it is a research which is not visible. Research is not visible. It is only search. Research has re and search. Sorry, I am taking you into the different domain. But research having two words, re and search. Search it, repeat the search multiple times till you don't find the solution. So that's why it took that much time and maximum time it will take. Thank you. So this is what about the problem formulation and the solving. The very important 4 steps that define, analyze, isolate, and then choose the best problem solving techniques. Now taking some small examples, not taking too much time because you all know, and this is available on Google itself, that we normally formulate the solution for the chess game. Like we know what are the legal moves. So the person must have, the developer must have, the user must have the idea that what are the legal moves. Whenever you are designing the board, the legal moves is very important. Otherwise, any items on the chessboard can move anywhere, left, right, at any position, any counts, it will take it. So that is what actually you can say the validity of the moves is very important. So first of all, understand the validations in the chess game. Legal moves are very important. Positions that represent a win. Any position cannot represent a win. There are rules. Okay. So how many positions that represent a win? Who will win? How many moves it will take? At what position it will go? At what position it will kill? At what position it will dodge? What can be different ways? It is not only the play, but also the winning condition which terminates the game. Everybody knows the terminations. Even though that means chess game algorithm is what is actually a very simple one that one should understand when the game is going to terminate. So you cannot only concentrate on cannot only on terminating the game. Understand the legal moves, understand the positions where these moves can makes you win, and don't play. Don't play. It's all about winning. Okay, the goal is what opponent does not have a legal move. Okay, normally we need to have opponent party doesn't assume that does not have the legal move. So king is under attack. That's what the main goal. That you always has to design a game in such a way that that opponent king should be under attack. Then only you can win. So practical difficulties are always there. Understand what practical difficulties will be there to achieve the goal. No person could ever supply a complete set of such rules. Yes, definitely. It would take too long and could certainly not to be done without any mistakes. Always there are mistakes. No programs could easily handle all those rules. Okay, and although a hashing scheme, we normally know all hashing scheme, could be used to find the relevant rules for each move fairly quickly, storing is in fact a difficulty. You cannot hold back we cannot hold back all those rules. But today, I think it is made possible. We have a different beautiful chess games available, and the main goal, it was designed with this main goal that king is under attack and the opponent should not get the legal move immediately. Okay, some examples of this like that, you can have a pawn, how it moves to the next position from both the sides. So chess game, see this is what actually the formulation, okay, and getting the solution. So state space search. So normally it starts from one particular location, white pawn at square at file E and rank 2, and square at file E and rank 3 is empty, and file square these are all the functions. Okay, these are all the functions where the pawn is going to be placed, pawn is going to be moved, where the pawn is going to be moved, at which position. Square file E comma rank 4 is empty. So if this is true, then move on from square file E rank 2 to directly at rank 4. So advantage of this state space search, it allows for a formal definition of a problem as the need to convert some given situations into some desired situations using the set of permissible operations. See, very important definition. It allows for a formal definition of a problem as the need to convert some given situations into some desired situation. Given situations to desired situation mapping, converting given situations to desired situations with permissible operations. That is what actually your problem should look like. It permits us to define process of solving a particular problem as combination of known techniques and search. Search is very important process in the solution. Search is very important process in the solution of hard problems, which is undeterministic in nature, for which no more direct techniques are available. So keep in mind these two important aspects of this. I think you all know more than me about the chess games, and might be you people have already worked on it. So this is what I'm an example of this. Water jug problem, very well known universal problem. You are given two jugs, a 4-liter one and a 3-liter one. There are two jugs, a 4-liter one. So this is now you can say the question for all of you, that how we can solve this. We have two jugs, one is of 4-liter and second is of 3-liter. Neither has any measuring markers on it. No jug has any measuring markers of any liter. Normally jugs doesn't have any marking. There is a pump that can be used to fill the jugs with water. Yeah, there is a pump that can be used to fill the jugs with water. How can you get exactly 2 liters of water into 4-liter jug? Now 4-liter jug doesn't have any marking. It has a pump. To fill the jugs with water, and now you have to fill. You have to get 2 liters of water into 4-liter jug. How you can do this? Okay. So might be you people can Google it. You will get a solution immediately. So I am moving into the next. So you can Google it, no problem. The same information you can also see the same information. I am also feeling intention is to explain you formulating various moods in the different spaces and finding the solution for the same. Okay. So need not to explain whole things in this way, because it is already 12:10. Okay, lots of things to prepare, lots of things to there for me, because again more 50 slides are there. Okay, so here it's a condition. The condition is given, the rules are passed. According to the condition, the rule will be act upon. Okay, and here the definition is given. First it will fill the 4-liter jug, then fill. So y is for 4-liter jug, x is here again fill the 3-liter jug. Okay, xy, if x is greater than 0, so x pour some water from x pour some water from 4-liter jug, pour some water from 4-liter jug, x minus d comma y, then x comma y minus d, pour some water from 3-liter jug. So the condition is x from xy, if y is greater than 0, then this will happen. And then if again x is greater than 0, empty the 4-liter jug on the ground, empty the 3-liter jug on the ground, pour the water from 3 liter jug into the 4 liter jug. Yeah, put 3 liter in 4 liter. Okay, just a minute. What's he has typed? Put 3 liter in 4 liter. Fill 3 liter in 3 liter jug. Put 1 liter in 4 liter. Now you get 2 liter in 3 liter jug. Empty 4 liter jug and pour it in 4 liter. Yes, ma'am. Swapnali, thank you. You have solved it immediately. So this is what actually you have the solution. But what happens for the normal people? Okay, how it tries, how it takes a different sequence of actions to be taken place. Thank you, Swapnali. So this is what actually at the end, pour the 2 liters from the 3 liter jug into the 4 liter jug, empty the 2 liter jug in the 4 liter jug on the ground. Yeah, so these different rules has to be formulated to get the proper solutions for this water jug problem. So finally, the table look like this. For the sake of understanding, liters in 4 liter jug, liters in the 3 liter jug, and rule applied. What rules we have applied? In the earlier, the rules which is given has to be applied. Okay, accordingly you will get the answer. Now, the next is about the problem description. Therefore, in order to provide a formal description of any problem, one need to do the following. So this force, again, I am repeating that we need to define the state space that contains possible configuration of all relevant objects. First, define the state space. Second, specify one or more states within that space that describe possible situations from which the problem solving starts, which are termed the initial states. Then specify one or more states that would be acceptable as solutions to the problem, which are termed the goal states. Then specify a set of rules that describe actions or the operators which is available. Then problem can be solved using the rules which can be combined with appropriate control strategies. So these 4 steps are very general and natural to all problem descriptions, means formal description if you want to solve. So this is what 4 steps, you can say the 4 things need to study. The example problems, some examples which are taken like toy problems illustrate or test the various problems solving methods. In concise and we need exact descriptions can be used to compare the performance. The toy problem examples like 8 puzzles, 8-pin problems, then flipped arithmetic, vacuum wall, missionaries and cannibals, simple route finding. All these are the simple examples which you can try. These are the toy problems. Okay. The real world problems are more difficult to describe. So no agreed upon specification because it's very difficult. Okay, because we cannot see, the solution is not visible. We always attempt to get the optimal solution, acceptable and measurable solution which is required. And finally, at the end, it is totally up to the user. It is totally up to the user whether it is acceptable or not. So depends. Examples like route finding, yeah, different examples are there. Route finding, maybe in the networking domain, maybe in the transportation problem, maybe in the heart surgery, maybe in the photo detection, maybe in the object detection, maybe somewhere, everywhere, route finding is very, very important. Okay. And there are lots many algorithms available for this. But again, I told you that finding the best solution is very difficult. Best VLSI layout, robot navigation, assembly sequencing, all these are different real world problems where you can try upon. The type problems like the vacuum world problem, again, the due reference, I would like to thanks the Google and the internet resources through which I have collected these examples and PPT and presenting in front of you. Again, I am giving my due respect to all the peoples and the researchers and the authors who had put it on the internet sources. The vacuum world, everybody knows. Already I have told you and explained you. There is total 8 possible states. The world has only 2 locations. The world has only 2 locations. Each location may or may not contain dot. The agent may be in one location or the other. 8 possible world states has been given here, and the 3 possible actions it can take: left move, right move, and it will suck the dirt. The final goal to achieve is clean up all the dirt. You can just have the look on the PPT with these 8 figures. Okay, the dirt is given, the vacuum cleaner symbol is also given: 1, 2, 3, 4, left move, right move, fifth, then 6, then 7, and the 8. Okay, so all possible combinations. So all possible states are very, very important to understand. Assume if any one of the states in your problem formulation is missing, then your solution may be leak sometimes. Your solution leak in the sense may not produce the accurate results, acceptable result which we are expecting. So significance must be given to each and every states, each and every sequence of states in the problem statements. Don't miss it out. Then yeah, different. This is already I have explained you, so need not to worry. States, that is again one of the 8 states given earlier. Operators, move left, move right, and sub. Goal test, no dirt left in any square. And path cost, each action cost 1. So cost is very important. So you very important path cost. It will clear the dirt, no problem. But what is the path cost? It cannot take the maximum cost to reach to the dirt and clean it. So battery life will be reduced now. So whenever you devise and you want your vacuum cleaner to be intelligent enough, so also take care of the path cost. Also take care of the component, which is very much important for the vacuum cleaner. So normally we forget to take care of the path cost. We only think about that vacuum cleaner must clean in any way, but also think about the path cost. Okay, this is also very, very important for getting complete formulations to your problem and getting complete solution. Now, dear participants, moving to the next title. This is again related to the ML part and then little about the case studies. The machine learning, hope everybody has already understand. So I'm not taking only 1 minute will take it. So yeah, machine learning is study of algorithm that improves their performance at some tasks with experience. Okay, that's a definition. Okay, and optimize. Purposefully I have taken it bulleted. Okay, study of algorithm that improve their performance at some tasks with experience. So it optimize a performance criteria using example data or past experience. So we normally use the statistics for taking an inference from the sample, or you can write an algorithms to solve the optimization problem or representing and evaluating the model for inference. So I think all of you know about this fact. So let me move ahead. Classification, everybody knows that example of credit scoring, you have this simple and beautiful graph, and high risk customers and the low risk customers are properly separate out. So this is a simple linear separable problems. So you can see violet color stars are low risk and the red color are high risk components. Okay, and as if you can see the discriminant, it is differentiating between low risk and high risk customers from their income and saving. So discriminant, if income is greater than theta 1 and saving is greater than theta 2, if income is greater than theta 1 and saving is greater than theta 2, then low risk. Yeah, if it is greater than theta 1, yes, it is income. This is an income, x is an income here, and y is a saving. Theta 1 is representing the income parameter at some coordinate. So if income is greater than this theta 1 and the saving is greater than this theta 2, it takes the customer into the low risk, else it is high risk. So this is simply linear separable problems. This is simply classification. Then classification applications. I'm sorry, I'm reading this. I know this is not visible to you. From my side, I think there is certain. Let me do that part. Make it black. I think this is visible now. Okay, so this is again some examples of classification like ACA pattern recognition, face recognition, pose, lighting, occlusion, makeup, hairstyles, character recognition, you have different handwriting styles, speech recognition, you have temporal dependency. So you can use use of dictionary or the syntax of the language, sensory fusion. But speech recognition is a difficult and challenging and NP hard problem. Okay, it is not very simple. Usually you can understand from the lips some pronunciations and some acoustic for the speech, but again it is not up to that level which we expect. Medical diagnosis from symptoms to illness we can so all these will come in the classification category of ML. The examples, training examples, normally we give training example and normally then we also give the testing images. So testing and training images, normally we from the given 1000 samples, so we first bifurcate that 700 will be training and 300 will be testing. So ResNet allows you to combine these two. In case of the marks RCNN, when you create a marks RCNN file, JSON files of the training and the test, you need one combined files. Okay, you need JSON of test as well as you need JSON of training. But your Colab, your ML, your TensorFlow, take it as one JSON file only. So you need to merge it together. Hope you know about this part. So face recognition is a beautiful, well-recognized examples you can apply. This regression already you people have done. Price of a used car can be calculated using a simple equation y equal to wxw is similar to your y equal to mx plus c. So this is the y as a price you can apply to this particular model G model, and the parameters can be used to calculate the price of a used car. Okay, so depends upon the mileage, depends upon the mileage and the depends upon the mileage, the price of the car can be reduced. Yes, definitely, because it degrades the performance or performance of an engine. So as the performance of the engine degrades, automatically the cost value goes, price goes down. It's similar. Then this is the fact that when you purchase a car and you take an insurance, so after 2 years, after 3 years, you get a minimum value to protect your car, but the cost and the price of the car gets reduced. Okay. Regression application. So normally these peoples are used in the banking and the insurance sector. Such kind of applications are used. So they formulate the problems according to this way only. It's a very simple. What should be the price of a used car for which the customer would like to renew the insurance? So this is simply the mathematics they are using and put it into the regression domain and give the predictions that this is what is the possible prediction cost which you would like to give. Okay, so lots of things are there. At the other end, you can think in terms of company perspectives also. Their benefits and cost and the profit and the loss are very important factors. Then only they use it. Regression, another example is like navigating a car at a particular angle of the steering wheel. So this is one of the example in the CMU Nav lab. Then they make the use of kinematics of a robotic arm and calculate the alpha 1 and alpha 2 first before alpha 1 and alpha 2 before designing the steering wheel and the angle at which the steering can move in the car. So you just think it about that in a driving, in a selfless means driverless car, how this angle of steering wheel is calculated. What is the kinematics of robotic arm? That's an interesting problem for all of us to understand. That what should be the angle of the steering wheel they have considered, because there is no driver available. So and there is no nothing. Only the car is operating in a free environment. So how it takes care of all obstacles and the steering wheel, the speed, the accelerator, and everything. See, understand and read the paper very nicely to get more and more details about all this type of ML, AI, and data science components. Then about this, which is again repeating supervised and unsupervised learning, supervised learning uses the first one. The supervised learning uses decision trees that create the rules. Prediction of the future cases you can do. So you can use the rules in case of supervised to predict the output for future inputs. The first 4 points are for the supervised learning, and the remaining are for the unsupervised. So we normally use the supervised learning to extract the knowledge. The rule is easy to understand. We use it for compression. The rule is very simpler than the data it explains. And the outlier detections, exceptions that are not covered by the rule, example, the fraud. So for all this, we normally go for supervised where data is labeled, data is known, teacher is available. All this comes in supervised learning. Supervised, you know the output, it is deterministic in nature. Okay. While unsupervised, it is undeterministic. We don't know the output, even we don't know the inputs to learning what is normally happens. There is no output, just like a small fish who learns how to swim in the water from the various activities of her mother accordingly. So those who learn himself. Today we also learn many times by ourselves by listening to the various videos and making our own perceptions and own understandings and try to fit it and then try to apply it and try to recall whether it is really getting the correct response or not. So, but it takes a time. But it takes a time. Clustering we normally do where it is nothing but we create the groups of similar instances. So clustering is there in case of unsupervised. Other applications like text summarizations, association analysis, lots of association analysis you can do. You have the bread milk examples, which is basically used to explain about the association mining and everything. Okay, even the car price or a mobile price or the depend what it may be, there are different. That's why I told you that don't be hurried in deciding the various algorithm or the solutions to be applied to solve the particular problem, because you need to understand its ins and outs, and don't forget about the cost part. Then other applications in this, like customer segmentation in customer relationship management, that is CRM. You can use image compression, that is mostly for color quantization. So today's most of the applications are available with us on mobile, which uses the image compression, color quantizations. Your look is completely getting changed, and see the miracles in today's application just because of various AI, ML, and data science techniques. Bioinformatics, you can learning, that is motives. So huge is again a demanding field. Most of you are very much I think worried about the reinforcement learning. So it's, yeah, definitely it is challenging field, because what actions should be an agent take in a particular situations. Policies definition is very difficult, because we cannot make sure what actions should agent take in a particular situations. It is completely 50-50%. Utility estimation, how good is a state. So normally it is again made by the policy, and we don't know whether the policy will be perfectly fit for the particular problem or not. No supervised output, but delayed reward. There is no supervised output we are receiving through the reinforcement learning. But definitely the reward is there, but it is delayed. The example is given like credit assignment problem. Normally when we take a home loan, or the when we purchase a credit card, or when, so our data is taken care by the different government bodies and different private bodies also. We unknowingly don't know wherever our names and data are there. Even my name is somewhere else, somewhere there. Then people are trying to contact me and trying to tell me, sir, your credit value is now this one. If you want to improve the credit, do this, do that. What was the responsible for that? What responsible for the outcome? We don't know exactly. So it is completely, it reinforced me. So 50% chances are there that can be improved, that cannot be improved. So game playing, again 50% chances whether it can be play, means it can win or it can lose. Robot in image, multiple agents, partial observability, all these are the things, applications where you can have this reinforcement learning. Learn actions to maximize the payoff. So reinforcement learning normally used to learn the actions to maximize the payoff. Payoff is only delayed. There is a reward, but it is delayed. There is a reward, there is an output, but it is delayed. Exploration and exploitations, you can do, you can explore, but again I told you that there is no guarantee, and there is no guarantee of the solutions which we are achieving. Only chances of saying 50% yes and 50% no is there. So many times the credit assignment problems, people are trying to improve their credits by taking the particular insurance, or by reducing or by taking the particular loan in the particular. The home loan capacity is also getting affected by the credit score of a particular individual. So that is what is one of the examples which I can tell you, that in case of the home loan, so normally the credits are very much important. Okay, so I know and I remember that the different banking sectors, they also have the different teams and the web portals available where they calculate the credit score for a particular individual and find out the eligibility of the particular persons. See how much amount of loan can be sanctioned depending upon his salary and the other loan factors which he had taken it, whether it has a home, whether it has a property or something says. So such problems will come in reinforcement. Vedic argument says, can any ANN perform clustering? Can artificial neural network perform clustering, or it do only classification? Artificial neural network, that is, you can say, madam, Koinun self-organizing map. If you remember, it does clustering and classification both. Artificial neural network is very big. You cannot say ANN is only the one backpropagation who does only classification or radial basis. But ANN also has a unsupervised learning techniques, like yeah, auto encoders can do. But simplify. I'm simplified the examples. Simplified with the Koinun self-organizing feature map. Do you know Koinun network? Koinun self-organizing map. Clustering does when the patterns in the data sets are learned to map itself. That's a clustering. Simple example is like you have an X-ray image of malignant symptoms and you would like to identify the cancerian and non-cancerian cells, malignant cells and non-malignant cells. So normally in clustering, we do groupings, okay, and we do grouping of those particular neurons associated with the winner neuron. We use the concept of clustering where we have to compete. Every neuron is competing with another neuron, and all other neurons nodes weights are associated very closely to the winner neuron. Then only the application can do classifications. Otherwise, only clustering will remain. Then it doesn't. It will not help us to do the classification also. There are so many examples ANN which can perform clustering. Hopefield is also there. Then you have associative memory networks also. So many examples available. So very beautiful and very well famous is self-organizing. Now people are coming with unsupervised self-organizing network. Unsupervised self-organizing network. Okay. Unsupervised self-organizing. Supervised and self-organized. Can we call it? Let me see the chart. Sir, as there is learning involved, can't we call it supervised? Yes, madam. Yes, supervised. Yes. Because you also need to do the training in the initial stage. So training is depends on the data sets. Now, if you have the level data sets initially available, and then you are expecting at the end that your model should also consider the unknown data set, means no unlabeled data set. So then finally at the end you get the unsupervised way of getting the solution. In practical situation, what is the difference between sequence code? So this is, we are going out of the scope little. What is the difference between sequence code and functional code in ANN? See, what you want me to answer in this? What you want me to, so can you just explain me with some example here? For example, you can unmute yourself from Venkata Dayasagar Ketraju. Hello, hello, Sri Venkataji. Can you just give me the hint in what context you would like to know from me? Hello, am I audible? Venkataji, you can unmute yourself and tell me.
Sir, you go ahead.
No, sir. Let the sir is going to.
Sir is there may be some issue. Sir is not unmuting. So there may be some issue. Sir. He's not unmuting.
Wait for 2 minutes, no, sir. They may ask me about LSTM model. He may have certain different thinking. He may working on some LSTM to the sequencing related. He asked me about sequence code and functional code. That's why. So what he want actually, let me understand what he is looking for. So that's why. So now people also type na sir. So let me know what he is actually want. Sequence, what he want actually. Sequencing means what he want to, sequence code. Memorization tasks, normally we expect our model to learn from the learned memory capability. Normally all the neural network model, artificial neural network model has the generalization capability. It has a generalization and see, first it generate and then it respond. Generalization, and then you can simply say another word. First is generalization. It creates the data sets. It generates the data sets, and whatever data sets it generates, it learns from it and created the response which is expected to us. So most of the tasks, in case of the neural network model, depends on the memorization about the learning memory capability of the ANN. तो सीक्वेंस जो है आपका सीक्वेंस कोड एंड फंक्शनल कोड व्हाट so sequence problems there are difference whether it is a sequence what type of sequence one aspect of the sequence prediction like it may have the memory approximations also. So what he wanted to say, let me know. Sequence means again, some real values. You can have a sequence. Sequence code means between. If suppose you have a data sets available and you want the values between some real set 0.0 to 1.0 range, then you can have a time steps of the past values. Then your model can predict the next item in the next sequence. So sequence code is possible, sir. Sequence code is there in the ANN. Normally we do it. Okay, we do it. Okay, we do it, but depends upon the value memorization. We can means you can have random subsequences also. Lots of things are available. It means normally I just want to understand from you in what context you would like to know about this. So if it is clear, then I can again explain you, because I am also practicing weekly on the Colab using the various deep learning techniques. That's why I'm going to ask you that I will help you to clear this doubt. There is no hurry. There is no such hurry to. Okay, so should I move ahead? So I think you understand means sequential, sir. Okay. Thank you. So I think you understand coding all apart. Means most of the times it is given sequence coding. Yeah. See, bitmap image data storage format, or normally we work on it. Okay, and then it gives us the more data. So that is also one of the example. Okay, and it is, yes, it is there. It is possible. So yeah, it is. So both sequence code and functional code, sequence coding is possible. Basic, it is nothing but is a basic algorithm. Huh? It's a basic algorithm, and sequence code explains sequence. Again, one example I can simplify it. Sequence code is a simple example. You can simply say that you can, and there is a functional code also. So in that context, I think, yeah, it is good to say you about that sequence code, which is a simple basic algorithm, a logical steps, a very simple logical steps in the form of some algorithm to get the desired result. Yeah. And functional code, normally applying functional code is little different from the sequence code, which implies on getting the final response. Okay. There is another examples here, like missionaries and cannibals. Missionaries and cannibals is, again, I have taken it from the Google itself. Just only for the sake of understanding, the 3 missionaries and the 3 cannibals want to cross a river. There is a boat that can hold 2 people, cross the river, but make sure that the missionaries are not outnumbered by the cannibals on either bank. So here there is a lots of abstractions. The abstraction like crocodiles in the river. There may be crocodiles in the river which is hidden. The weather and so on. Only the endpoints of the crossings are important. So understand that abstract when we start formulating and start preparing the solution. So solution is sequence of action which leads from the initial state into the goal state. That means the sequence of actions that gets the missionaries safely across the river. That's the solution. Or sometimes just the goal state. Infer molecular structure from mass spectrographic data. So that is just one example for problem solution. Next. This is again one of the 4 different examples. Hope everybody like this. I have taken it from online resources and some of the IIT professors PPT. Example, that is Netflix application. Everybody knows automatic product recommendation application. And important, this is the important. Yeah, this is a modern shopping. We say modern shopping or future shopping. Prediction goal is based on past preference. Predict which movies you might want to watch. Yes, this is how Netflix is designed. It understands your past preferences, it understands your choice, and predicts, helps you to give prediction what movies you would like to watch in the future. Data. Fast, today's these bots are very intelligent than us. You travel today by aeroplane from Mumbai to Punjab, Mumbai to Chandigarh. Next time, if you have booked the ticket through Yahoo or Gmail, automatically it takes you into the deep. Understand where you purchase, where you move. It extracts the data from your location. It understands the data from the purchase you have made in the shop. It understands the way you used. It understand the everything. It understand and try to capture the data, fractional data in all dimensions, and does the predictions what you like, what you don't like. This is what is. So now what features you want to add in the Netflix which you have not observed? Think upon it. This is what for all of us. Next example is zip codes application. Everybody knows automatic zip code recognition. Importance, this is again modern delivery of small goods. Goal, based on your handwritten digits, it predicts what they are and use them to route the mail. Try to use this zip codes. Data, black and white pixel value only. For Netflix, the data was only past movies you have watched. For zip codes, the data is black and white pixel values, and the target is which digit. It explains you. Try to use it. Try to Google the zip codes and see what it does. Example, another example is call center application, automatic call routing. We don't understand sometimes whether the person is speaking with us or a robot is speaking with us. Important, yes, this is modern customer service, because every customer, if I call to someone, I am expecting that person should take my call. If he doesn't take my call, I will feel insult, that I will say, means he doesn't have the time to talk with me. So call center is taking care of all of you. If you call a particular call center of a particular bank, the bank is taking care of you in form of not physically talking to you, but they will make the bots available for you to talk with you and entertain you. And the chatbot entertain you and all your requirements and replies what you want. So prediction goal, based on your speech recording, predict which words you said and what data it takes it, fast recording of the various people. So they capture all this data. So where you move, how you move, by which vehicles you have traveled, what you eat, where you visit, what you wear, everything it considers. Today's world, nothing is hidden. All maximum devices, the phones and everything are interlinked to each other, and that's how we are the only people who are providing the data to the society and helping the society to ease the tasks for us. Okay. So call center, which word was intended? Okay, so which word was intended is what is the target and the features. You identify what features is remaining. The problem statements I am giving you the various examples, which definitely helps you, trigger you to have your own research problems to solve it. Problem formulations you can. Stock market, everybody understands, everybody knows. Automatic program trading, important. This is modern and future finance. Yeah, today's nobody visit, but today's through your application, through online way, we can predict the patterns, predict the stock, whether it will go up or whether it will go down. So the data for the stock market is absolutely the past stock prices and the target, whether it goes up or it goes down. What is missing here in this feature? To understand it, whether the stock market would like to lose the share, would like to lose the share, would like to lose the customer. So think what features is needed here to improve it. Whether in future it may happen that the person expressions can be captured, whether the person is really interested to purchase the shares or not, whether he is, how much interested he is to purchase the share, maybe can be captured by the voice, by the speech, by the face in future. Might be the stock market becomes more intelligent. So those features can be added and make the stock market really amazing and make your task so simple. They understand from your speech whether you are interesting, how much interest you are to purchase this or not. So this is possible. So the real world problems, examples, lots of examples in this today's sessions from my sides to all of you. And the route finding defined in terms of locations and transitions along link between them. The applications, yeah, definitely route finding is defined in terms of locations and transitions along links between them. The applications is routing in computer network where the network, the shortest path need to be found to route the package in a very short distance. Might be many of you knows about these various algorithm like via OSPF, open shortest path first, then Dijkstra algorithm, and lots of crucial algorithms. Lots of algorithms are there in computer network which helps to reduce the round trip time, RTT. Okay, so main focus is to cost path. Okay, very important is cost path. Automated travel advisory system is also there. Airline travel planning system is also there. These are all the applications. Okay, where you can. Then touring and traveling salesman's problem. Very visit every city on the map at least once and end in some city. The Bucharest is given. This information is about the visited cities. So this is what actually the problem. The statement goal is find the shortest tour that visits all cities. Find the tour that visits all cities. So it's an NP hard, but a lot of effort has been spent on improving the capabilities of traveling salesman's problems algorithm. So this is what. So again, more efforts can be spent on improving the capabilities. Applications are large, like planning movement of automatic circuit board drills. So there, this SLP can be useful. Okay, because designing the PCB printed circuit boards and keeping the VLSI chips on the board and understanding the cost path is really very much important. Now today you can see the processor size or the board size from earlier days to today's days, how it is properly placed with minimized and optimized way of placement of different components. So VLSI layout is also one of the real world problem. You can say place cells on a chip so that they don't overlap and there is a room for connecting wires to be placed between the cells. So this is what it's. Then you can think about this and search the problem, search the solutions in all different aspects. Robot navigation, generalizations of the route finding problem. So assume you have a robot in industry or in a mall, then how it takes place, how it generates the route or how it generates the routes. So there are no discrete set of routes. Robot can move in a continuous space and infinite set of possible actions and state is there. Assembly sequencing, complex object, automatic assembly of complex objects, and the problem is to find an order in which the assembly part of some object. So these are all some small examples to only know about the work. That is, you can identify the use of AI ML techniques and the procedures which can be possibly best fit to get the most optimized solution. Normally, yes, many shows that we have talked much more about this agent, then lots of things about the algorithms, about the problem solving, formulations, and so many things about the abstracts also, which is very difficult. Some things remains, in designing the solutions. Sometimes we miss some parts. So what parts we are missing? So that need to be understand. Like in this one example, like this in one example here, it say that there may be possible that there will be crocodiles in the river. Okay, so just take in mind that yes, there may be, so you need to think in that way. So evaluation criteria for search technique, there are so many search techniques, generalized search, optimized search, so many different types of search techniques are there, and beautiful examples are there in discrete graph theory and structures. Okay, so in that context, you can say what is the importance of these techniques. Okay, and what are the evaluation criteria for the search techniques? Space is one of the important parameters which maximize the number of nodes in a memory at one time. Optimality, does it always find the best cost solution? cost can be considered. Cost considered sum of the edge cost of the path to the goal. Then it should be completeness. These are all evaluation criteria for your search algorithm or search algorithm. Space calculation, optimality checking, completeness finding. Does it find a solutions when one exists, and how much time it will take? How much time it will take to search? How much time it will take to reach to the respective location? The number of nodes generated. How much nodes will be generated during the search? Lots. So this space, optimality, completeness, and time, these are the 4 important parameters to evaluate the any kind of search technique, search algorithm, or search criteria. You can say search methods. Time and space complexity is measured in terms of these 3 important parameters. The first parameter is B, that is maximizing the branching factor of the search tree. We will assume B is finite normally. Then D is another important parameter, that is called as the depth of the shallowest goal, and the M, that is the maximum depth of any path in the state space. It may be infinite. So keep in mind these 3 important parameters to understand the time and space complexity. Performance measures of a problem solving algorithm. I have already told you we can evaluate any algorithm performance based on these 4 parameters. Completeness. Again, I am simplified this. Is the algorithm guaranteed to find the solutions if there exists one? Then optimality. Does the algorithm find the optimal solution? Question mark. Time complexity. How long does it take for the algorithm to find a solution? Then and space complexity. How much memory is consumed in finding the solution? So memory calculation. So normally we say space complexity. It's the code optimization, memory code optimization is very important. So how much amount of memory? It should definitely consumes less amount of memory to execute the solution. Now here the last I'm toward the last part of my presentation, having a small examples from my own paper. All these are my own paper with my students. So the first paper is on smart farming system crop yield prediction using the regression techniques. So in this smart farming system, the attempt is to get the crop yield prediction using regression technique. This was the paper in, I think, 14-15. So the smart farming system. So normally we know that there is always a demand, increase in demand for the food. Hence, new methods need to be devised to increase the crop yield. So an attempt to define, this is what an attempt to define the problem in the paper. So we know different intelligent way to predict the crop field and suggest the optimal climatic factors to maximize the crop field. So what should be that factors? Using machines and control systems to automate the processes and optimize the productivity. This was again one of the tasks. So we use here the 3 different techniques, that is multivariate polynomial regression, MPR, support vector machine regression, SVM, and random forest models to predict the crop yield per acre, that is random forest. So 3 techniques are compared at the end. You can see the result. The parameters used in the data sets are humidity, yield, temperature, and the rainfall. These are the 4 parameters in the data set. Then these predictions will help the farmer choose the most suitable temperature and moisture content at which the crop yield will be optimal. So this is what actually we are trying, that the most suitable temperature and the moisture content to get the crop yield more. Okay. So and also we use this error cost functions, that is root mean square error. Can you explain? I cannot break my speech in between immediately to get the answers. At the end, I may expect the questions from you. Okay, or you can unmute yourself and can speak, please. Let me complete this case study first, and I think sir can give my number, and we can have a discussion, sir, in large. No problem. I am the person who can speak with you for longer hours of times if it is on the research and the study. Me and Rathod sir both, no problem. From our side, we have enough time to talk on the research and the various parameters. So this smart farming paper, just talking the use of RMSE, MEE, and the median absolute error. So R square values to compare between these 3: MPR, SVM, and RS. And the methodology which was there in this paper was methodology. First, we need to have a data set. So we have obtained the data set from USDA websites for state of Iowa, which was available. Then units, that is the system is supposed to fit a regression model, which would help us predict yield of a crop as function of monthly temperature and rainfall. The system will make use of regression because we need to predict the yield based on the historical data of yield versus environmental parameters, and that's why regression was one of the best fit technique. SVM was also used and tried. Multivariate polynomial regression gave RMSE value of 9.4. In order to improve the accuracy of systems, SVM regression was used. So on the given data set, SVM attempts to fit the hyperplane. So I think everybody know about the hyperplane. Random forest algorithm tried because it enables us to do ensemble learning, okay, for classification, regression, and the other tasks. This was the result. You can see in the first graph, MLR, RF, and SVM techniques, okay, which on the data set 426. So these three values are calculated. RMSE, MAE, and median absolute error. Okay, and the right side we have the R square value of the three models. So this was the paper with the students itself. The study paper before 5 to 7 years back. An attempt to formulate the problem for crop yield. Nothing great. The second one was activity recognition and fault detection in elderly people. We normally know that old age people's, elderly people's, when they fall, someone will be there to take care, how to understand and recognize their activity and detect when they fall. This was an attempt. Okay. So the problem was there. So the abstract was written for the, like in today's COVID-19 situations, the need is increased to take care of these people's abnormal activity and fall. So we have studied why not the camera shall monitor the object activities and also observe the falls so that the system can give alert. Okay, so there are two models in this particular paper. One is activity recognition model and second is fault detection model. So first you can say activity recognition, what the person is doing, and second is fault detection, how the person is detecting whether it is fault. Okay, so the methodology here, the methodology is also given here. So single shot detector mobile net model is used. So here you have the input video through which the frames are extracted, it resides and construction of the blocks first. Then it provides to the SSD mobile net model we have used. Okay. Then you SSD mobile net model is used. Then we create the bounding box and calculate the difference between the various coordinates. And if x is greater than y, then object is equal to person. It recognizes that object is a person. If it is yes, then if it is false is detected, then it sends the alert. Okay, it sends the alert. Similarly, second case, activity recognition model, we use Markov model and probability of occurrence of sequences is calculated. And if that probability is less than the respective threshold value is also studied. It took normally, I think, six months to complete, means to take the decision whether what should be the threshold value. It is not simple. But finally, we have come to one conclusion and decide the threshold value to be taken. Then probability, we have put the condition if probability is less than this threshold, then it will detect as an abnormal activity, else it is detect the normal activity. So this and here in this case, if it calculate the difference between the coordinates, if x is not greater than y, if it is less than y, then automatically then there is no fall detected. So there is no actions to be taken place. So there is no searching takes place up to the alert. So here the function gets terminate here. But here the sequence, you can say the functions is going to be that means the call is going to be passed to the next class to detect whether the object detected is a person. If it is a person, then the call is going to be detected. This is what. So I think some of you may identify some sequence which which can be missing here, and this method can be improved further. This paper is available, sir. On all these papers are published in IEEE, Springer, elsewhere, everywhere. Okay. No paper I have taken which is not presented anywhere. Okay, not in small national conference or anywhere. It is all at about good conferences. Activity recognition, we use kinematics human action video datasets, and it is trained on 26 classes like cooking, extinguishing fire, and reading and sneezing. So these are the classes we trained. ResNet 3D model is used to classify the frames into the activities. 3D kernels are used instead of standard 2D filters. Here, frames are converted into the tensors and then it is passed to the ResNet. Okay, frames are converted into the tensor and then it is passed to the ResNet model. And highest prediction is the label. Markov model we used, that is transition dependent on time taken and current state. So the P current state is calculated. P of current state is equal to P of previously obtained multiplied by corresponding value from the transition matrix for the current transition, and the threshold is 0.2 we have taken. And if P of current state is less than the threshold, then it will detect the abnormal activity. Okay, this is what is the Markov model does. The fault detection, that is single shot detector mobile model, net model is trained on the COCO dataset. So we normally download the COCO dataset directly from the, in Google Colab, you can directly download COCO dataset and it gets the immediately stored, and then you can use the COCO dataset. It is a very used dataset for all types of work. So bounding box is formed around the person with the dimension. So this is what is the bounding box dimensions. So from model.py file, this is what the calculations of width and the height. W is width and H is height. So width is again the scale multiplied by the aspect ratio of that particular frame, and height is nothing but scale divided by the square root of aspect ratio. This was the formulation. So it gives us the W and H values. And then calculating whether it is standing or sleeping. So if dimension that is Y, and y minus x is greater than or equal to the less bounding box is vertical, then it is standing. Then second case, if it is more, then it gives the horizontal position, that is sleeping. So when bounding box is horizontal, so when the bounding box is horizontal, then it detects that if the fall is detected. You can see in the result. So results, first case it is normal, second case it is horizontal, bounding box is horizontal. It is just what as an attempt. So more improvements can be made. You can talk about validations and everything. So some answers, even I cannot give some answers to you if you talks in terms of the validations. Okay, there are improvement. There is a scope to improve this particular model. So this is reading newspaper activity, and this is blowing nose activity. These activities are recognized, and yeah, more real data sets can be bring together, and this research can continue and give the results. Activity sequence, the probability which we have obtained for reading and brushing, scrambling eggs, and the scratching arms. This was the probability, which was not too good, but it is fine. Activity sequence for cooking, crying, stretching, and knitting is again, this was the probability. Okay, this was all the actual results which we have tried. So yeah, more improvements is needed. This model can be more furtherly, accuracy can be improved. Fault detection accuracy is only up to the 60%. So again this accuracy, then removing the noise from the frames, more and more things, more research is required in this context. This is what an example. So problem is formulated up to certain extent, but it can be improved further. It can be improved further with other techniques. Then the another case study is about, these are all about AI and ML for real life problems. Physiotherapy. Most of you know about physiotherapy and how much they charge to give us the treatment. Okay, so why not it is possible for us to keep ourselves in front of our mobile camera and do the activity which is suggested and advised by the physiotherapist. And then while performing the activity, if there is certain activity or certain steps which we are missing, so our ML model, which is suppose in the form of an hardware, give an alert, or at the end it will tell us the wrong steps which we had carried out. So at least if our system predicts us about the wrong sequence of steps which we have taken during the particular treatment, definitely I don't need to go to the physiotherapist daily. I can do it at home. So this was what actually the problem, and it is formulated using some mathematical techniques in machine learning with the help of hardware, and attempt is made to understand whether it is possible to understand the physiotherapy, understand the some treatments, and whether it is possible to take care. But nowhere we are trying to replace any particular physiotherapist or oncologist or dermatologist or anywhere, any doctors. Okay. Yeah, teams. We all know about the system global view. So normally when we formulate the problem, we should study what is there in the universe. We normally know there is a, normally in case we know the therapist, okay, this is in a physiotherapy clinic, okay. And then you have a therapist, supervised session is taking place and supervised patient, the Kinect sensor will be there. Okay, but now in this case, the patient, the doctor is available. Okay, therapist is available. In another case, you have a Kinect sensor and there is no doctor available. Unsupervised patient don't know what is there, and it is at the house. So this Kinect sensor is taking the place. Then here actually the attempt was here to make this ML model more intelligent in case of home, uh, in case of giving the treatment to the patient at home. So we know about this physiotherapist. Identification of the problem at present, one physiotherapist was available for every 7 patients. Maybe this number may be changed now. The ratio is very less in India. In accessibility of physiotherapy treatment in rural areas, normally no. Many people does it in one way, and physiotherapy requires personal attention, time consuming, and it is costly process. So success depends upon the extent to which the patient adheres to the treatment plan. If it is not, then it doesn't. Okay, but normally we use. Now this is, you can say, firstly tracking. So steps used in this, what firstly tracking the human motions using the low cost Kinect sensor and IMU. It's a small chip. It Kinect as a sensor intended to classify the different body motions, and the IMU chip is used to calculate the geoforce. It for geoforce. Okay. Secondly, it includes band that generates vibration patterns, which informs the patient about the correctness of each various movement. It is intended to be useful and effective tool for remote physiotherapy sessions, allowing for a considerable cost reduction. But yeah, the cost of the Kinect sensor is, so we are always trying to use the a small IMU chip which is taking care of the Kinect sensor. So in place of the Kinect sensor, we can use IMU chip also, because you know Kinect sensor has emitters, IR emitters, have color sensor and depth sensor and tilt motor. So using this Kinect, you can even calculate the depth also, but it is hardware and it is costly. So attempt was always to have the another way of fabricating a small intelligent chip and embedding the machine learning algorithm to take care of such kind of treatments. That was an attempt. So more improvements is needed. Everything is possible. This was the flow graph, simple flow graph. Initialize the Kinect, enable the skeleton stream, track the skeleton. You have started, assume you have started the activity suggested by the physiotherapist. Then collect the hand joint location information. So it collect that, and then track the movement using the depth sensor. If there is any missing in the moment, if there is any missing in the steps which you have, then automatically it analyze if it is correct or not and give the feedback. That was the only aim of this particular research work, and this was one of the best project by Cognizant. Okay, so this was what actually about this one, that one of the simple examples that I have told you, that this IMU was very important here, internal measurement unit. This was used as an electronics device which measures and reports body specific force, angular rate, and sometimes the magnetic field surrounding the body using the combination of accelerometer and gyroscopes. Sometimes also magnetometers is used to determine the correctness of the exercise. So we are suggesting that instead of the Kinect sensor, why not to use the IMU chip in your device. Okay, that was, so the cost is definitely gets reduced. So that was our observation, that instead of the Kinect sensor, we can make the use of IMU chip so that the Kinect sensor cost will be reduced drastically. Yeah, more improvements are required in that case also, and in case of the algorithms also, in case of GUI also, so many. No research, you can simply say, is perfect in the world. Okay. The another case study, I think this is the last one. No, afterward there is one more, and then we will end the session. The modeling machine learning for analyzing the crime news. I think today most of us knows about the crime news, and we normally stick to that news through TV channels, through mobiles to read on And today's, I think most of us are afraid of taking the newspaper physically at the home. So we are now habitual of reading the newspaper from the mobile. Finally, it's okay, fine. But at the end, sometimes various types of crime news comes, and normally crime news focuses our attention. So here the attention was, there are so many crime news, but analysis was not there. This is before just 1.5 year back. One of the project done by by our students. Use of machine learning is use of machine learning for classifying the news into the crimes and non-crime. And this was a live project and really good. Classification of real-time news is performed, and it is and yes, definitely we have find the we have find the analysis by this tool is very good as compared to the past news. So traditionally we normally do the analysis of the crime, but crime news are normally not appeared in one particular paper. Different papers has different ways to describe the crime news. But what type of crime news it is, whether it is related to different crime news, whether educational, medical, accidental, sometimes politicians, sometimes various types of crime, or robbery, a bank robbery, whatever may be, any type of news. But analysis was very important. Okay. So technologies encountered currently are models developed for crime analysis. Some of the key technologies that have been explored previously, we have existing like SVM-based classifier, general architecture for text engineering, ANI, link pipe, OpenNLP, AJAX, a priori, K-means, Navy-based, classification correlation. All these are the technologies encountered. Okay, means we all seen or studied all this, and then finally come up with a very simple architecture. You have a crawled news. The news needs to be crawled. It is getting processed. This crawled news is an input. It gets processed, and there is a classifier, and it classifies the news. All the data sets is taking it from the data set. So we have taken no, I think most of the newspaper has not allowed us to use the data set, but those who are freely available, we have taken the use we have taken their data set as a training data set and applied to machine learning. So these were the steps. The URL of the website is need to be taken. Then the HTML code is generated. Classes of the HTML code of the websites are targeted for information gathering. After targeting the classes, the tags of the HTML codes are targeted, and text form of the tag is extracted from the website. And on that text, we do the analysis. One by one, the news is extracted and stored in the CSV file according to the entities. And this is how web crawling. So accordingly, it takes place. The last case study is the machine learning approach for predicting bumps on road. I have lots many research case studies which I can show you, but not time is limited. So here, very simple. It's a simple mobile-based approach using machine learning to collect the data from the accelerometer, which is inbuilt into every mobile handsets, and GPS also. So accelerometer and GPS we have used, stored in one database, applied the machine learning algorithm. This was again, I think 10 years back's work, and then the particular event is displayed on the map whether the particular road having bumps or not. So this was actually the steps to detect that you can see the bumps on the road, not the potholes, using the machine learning approach, getting the raw data, sending the raw data stream along with the time and location to the server, reprocess the raw data, use the high-pass filter to remove low frequency components, apply root square mean to on accelerometer values, define the threshold values on z-axis, then k-means clustering on training data sets is used. The model is built on testing data. Then random forest classifier is used to evaluate the model on the testing data, and then model is fit for making the prediction. So if there is a bump, then send back the locations to the Android phone, and Android will draw a marker on the Google map. Automatically shows on the Google map that at this particular location there is a bump. This was some views from the map. It is blurred. I'm sorry, but this was actually the result. So there are so many. So K-means clustering and the random forest we have used. K-means clustering is applied on training data sets to build a model, and our random forest used for evaluation of this model on the test data for the better prediction. So this was what actually from my side. I think it is right time I have ended. It is 1:15. Rathod sir, 11111 now. So I would like to thanks all internet resources, people, internet resources. Special thanks to Google who helps me to prepare this PPT and lots of online materials available at various websites. Time was very much little, lots of work. But thank you. Learning never stops. And again, last one simple message: if there is no learning, then there is no formulation. Thank you from my side. Participants, you can now ask. Ask in the context, ask only in the context of problem formulation and solving.
Any questions from the participants? You can type in chat box.
One has typed regularization, Sony ma'am.
Okay.
Sir,
Yeah,
can you
sir.
explain
Venkata sir.
regularization? So the word, so Sri Venkata sir, regularization, the regularization itself has a meaning. Itself has a meaning. The word regular. Okay, that means the word regular itself that to make the things acceptable. And that's why we use it. These are the techniques to reduce the error by fitting the function. Normally regularization, normally we use to reduce the error. We do regularize the the code so that the error can be reduced by fitting a function appropriately on the training set. And normally regularization is used to avoid overfitting, sir. So it is used to avoid the overfitting. And there are examples are there. Training data set, you can have some independent variables. I think you have already learned, like you have some you can have some independent variable. Training data set may have some independent variables, say x1, x2, and the target variable, say t1, t2. So you can simply say that target t can be obtained by substituting some value x into the respective function. So now you have your functions available. You can use Gaussian noise, you can use sine noise. So sometimes derivations are created. So this is so any real world data set you can take it. No data is perfect without any noise component. So main is what to find the patterns in the data sets and generate it to predict the corresponding target values. How much value, expected target value it produces matters a lot. Sometimes the problem can be overfit. So if the problem goes in the overfit, you may definitely get the deviations in the targets. So that is what regularization will help you to fit the model so as to avoid the overfitting. This is what is actually the regularization. Actually, in the context of machine learning, I have explained in the context of machine learning. Yes, Sony ma'am.
Thank you, sir. Anyone else would like to ask question? Otherwise, we will just.
So I have not taken much more time, huh?
Yeah. No, sir.
Yeah, thank you.
Okay, sir. We'll just end the session now. Sir, you rightly said that no learning means no formulation. Thank you, sir, for letting us know how to formulate real-world problems for artificial intelligence and machine learning. The case studies that you have explained were really informative. I hope that all the participants have gained most important insights that sir has covered through his session. And also they will be able to write many more takeaways from this session. Thank you, sir, for taking your valuable time and accepting our invitation at the very last moment for today's session. I kindly request you to please accept this virtual memento on behalf of our organizing committee. Thank you, sir.
Thank you. Thank you. I would like to thanks my committee, Rathod sir, Sony ma'am, and all the teams who allow me to speak. And thank you very much, sir.
Thank you, sir.
Thank you, Kalbande sir.
Thank you, sir.
Thanks, thank you.
Done,
So
sir.
participants will be,
Yeah.
yeah, thanks. Thank you very much. Thank you.
Yeah, so we will meet in the evening at 5 p.m.
Yeah.
Yeah. Okay. Yes, you all can leave for the time, and then we will meet at evening.
मी exit करू, sir?
Yes,
I will do
sir.
exit, sir.
Yeah, session is over. I am closing the meeting actually. Session is over. Okay.